In the last 72 hours, astronomers monitoring the interstellar visitor 3I Atlas have recorded readings that defy conventional understanding of how celestial objects behave near our Sun. When this enigmatic traveller reached its closest approach to our star, instruments across multiple space agencies detected something unprecedented. Instead of losing mass through the violent process of solar heating and sublimation that typically strips material from comets and asteroids, 3I Atlas appears to have done the opposite. It absorbed something. The data streams from NASA's Parker Solar Probe, the European Space Agency's Solar Orbiter, and ground-based observatories tell a story that has left the scientific community scrambling for explanations. During what should have been the most destructive phase of its journey, 3I Atlas emerged darker, denser, and fundamentally changed. Its spectral signature shifted from the familiar mix of rock and ice to something entirely different. New chemical fingerprints appeared in its reflected light, elements that weren't there before perihelion. Stay with me through this investigation, because what happened to 3I Atlas during those critical hours behind the Sun challenges everything we thought we knew about interstellar objects. If these findings hold up to scrutiny, we may be looking at the first documented case of an object that doesn't just survive close solar encounters, but actively benefits from them. And that possibility opens doors to questions we never thought we'd need to ask. If this mystery has captured your attention the way it has mine, make sure to hit that subscribe button and ring the notification bell so you don't miss any updates as this story develops. Your engagement helps us continue investigating stories that push the boundaries of our understanding. The transformation of 3I Atlas began during what astronomers call perihelion, the point of closest approach to the Sun. For most comets and asteroids, this represents a moment of crisis. The intense radiation and particle bombardment from our star typically strips away surface material, creating the familiar glowing coma and tail that make these objects visible from Earth. The physics is straightforward and well understood. Heat vaporizes ice and volatile compounds, solar wind carries away the resulting gas and dust, and the object emerges lighter and often structurally weakened. But 3I Atlas followed a different script entirely. As it approached within half an astronomical unit of the Sun, roughly half the distance between Earth and our star, something extraordinary occurred. Instead of the expected brightening from sublimating ice and the characteristic spectral lines of vaporizing volatiles, instruments detected what can only be described as an absorption event. The Solar and Heliospheric Observatory, positioned at the L1 Lagrange point between Earth and the Sun, recorded the initial anomaly. For several hours during 3I Atlas's closest approach, the object's brightness curve behaved erratically. Rather than following the predictable pattern of increasing luminosity as it heated up, the light curve showed sharp dips followed by gradual recoveries. These weren't the chaotic fluctuations of a fragmenting body, but rhythmic pulses that suggested something was actively regulating the object's energy output. More puzzling still were the spectroscopic readings. Before perihelion, 3I Atlas displayed the expected signatures of a metallic-rich interstellar fragment, with prominent lines indicating silicon, magnesium, and traces of nickel. But as it emerged from behind the Sun's glare, those familiar markers had changed dramatically. New absorption lines appeared in the spectrum, indicating the presence of ionized iron and chromium in concentrations that hadn't been detected before. The European Southern Observatory's Very Large Telescope Array captured some of the most detailed post-perihelion spectra, revealing chemical signatures that shouldn't exist on a natural object that had just endured temperatures exceeding 1,000 degrees Celsius. Instead of the depleted, weathered surface expected after such intense heating, 3I Atlas showed signs of chemical enrichment. Elements that should have been vaporized and blown away by the solar wind were instead more concentrated than before. Dr. Sarah Chen, lead researcher on the ESO observing team, described the findings in terms that barely concealed her bewilderment. The spectral evolution they documented suggested not just survival of the perihelion passage, but active incorporation of material from the solar environment. The object's surface composition had become more complex, not simpler, during its encounter with the Sun's corona. Temperature measurements added another layer to the mystery. Infrared observations from multiple space-based telescopes showed that 3I Atlas retained heat far longer than any known natural process could explain. Days after perihelion, when it should have been radiating away the absorbed solar energy and cooling toward the ambient temperature of interplanetary space, the object maintained a steady thermal signature. The heat wasn't dissipating randomly as it would from a simple rocky body, but appeared to be circulating through the object's interior in organized patterns. The Parker Solar Probe, humanity's closest emissary to the Sun, provided the most startling data of all. During its own close approach to our star, the probe's instruments detected localized disturbances in the solar wind that coincided precisely with 3I Atlas's passage through the corona. Where the probe's sensors expected to find the usual turbulent plasma flow, they instead recorded regions of unexpected calm, as if something was actively dampening the electromagnetic chaos of the solar environment. These quiet zones moved through space in perfect synchronization with 3I Atlas's trajectory, suggesting that the object was somehow interacting with and modifying the charged particle environment around it. The implications of such behavior stretch the boundaries of known physics. Natural objects don't create organized electromagnetic effects in plasma environments. They're buffeted by them, eroded by them, but they don't control them. Gravitational measurements from the Deep Space Network added yet another puzzle piece. Precise tracking of 3I Atlas's trajectory revealed subtle deviations from the expected orbital path. The object was moving slightly slower than predictions based on gravitational forces alone would suggest. This wasn't the random perturbation caused by outgassing jets that astronomers see in active comets. The trajectory modifications were systematic and appeared to be stabilizing the object's motion, rather than creating the chaotic tumbling typically associated with non-gravitational forces. Most intriguingly, these orbital adjustments seem to optimize the object's interaction with solar radiation. The small course corrections kept 3I Atlas in an orientation that maximized its exposure to the Sun's magnetic field, while minimizing the disruptive effects of solar wind pressure. For a natural object, such behavior would be an extraordinary coincidence. For an engineered system, it would be exactly what you'd expect from adaptive guidance algorithms. The density measurements provided perhaps the most unsettling data point of all. Radar observations from the Goldstone Deep Space Communications Complex indicated that 3I Atlas had become significantly denser during its solar encounter. The object's mass appeared to have increased by approximately 8%, while its overall dimensions remained unchanged. In simple terms, the same volume of space now contained substantially more matter than before. This density paradox violates everything scientists understand about how objects behave under intense heating. Thermal expansion should make heated materials less dense, not more. The only way for 3I Atlas to become denser while maintaining its size would be for it to have somehow compressed existing material or incorporated new matter from its environment. Neither process has ever been observed in a natural celestial body. The absorption hypothesis began to take shape as researchers from different institutions compared their independent observations. The term itself makes scientists uncomfortable because it implies active processes rather than passive responses to environmental conditions. But the evidence increasingly points toward exactly such active absorption of material from the solar corona during 3I Atlas's closest approach. Plasma physics models suggest that under the extreme conditions near the Sun, charged particles could, theoretically, be captured by strong magnetic fields and compressed into solid matter through processes similar to those that occur in laboratory fusion experiments. But generating and maintaining such fields would require energy sources and control mechanisms that no natural object possesses. The magnetic field measurements from multiple spacecraft paint a picture that becomes more extraordinary with each data point. 3I Atlas appears to generate its own localized magnetic environment, one that fluctuates in intensity and orientation in response to changes in the solar wind. This isn't the weak, static magnetization that some metallic asteroids display. It's a dynamic, organized field that responds to external conditions with what can only be described as intelligence. These magnetic pulses occur at regular intervals, creating a rhythm that has become as predictable as a heartbeat. Every few minutes, the field strength increases, charged particles in the surrounding plasma align along invisible force lines, and then the field relaxes back to its baseline state. The precision of this cycle suggests internal regulation rather than random electromagnetic fluctuations. When researchers overlay the magnetic data with thermal measurements, an even more remarkable pattern emerges. Each magnetic pulse corresponds exactly with a small increase in 3I Atlas's infrared emission, as if the object is converting magnetic energy into heat in controlled bursts. The correlation is so precise that scientists can now predict the timing of thermal pulses based solely on magnetic field measurements. This coordinated behavior between different physical processes hints at an underlying system that manages energy flow with remarkable efficiency. Rather than radiating heat chaotically as a heated rock would do, 3i Atlas appears to store, circulate, and release thermal energy according to some internal logic that optimizes its interaction with the solar environment. The implications of these findings extend far beyond the puzzle of one unusual object. If 3i Atlas truly represents a new class of interstellar visitor, one capable of active interaction with stellar environments, then our understanding of what moves between the stars requires fundamental revision. We may be looking at evidence of processes, whether natural or artificial, that can harness stellar energy on a scale that dwarfs human technology. As 3i Atlas continues its journey away from the Sun, carrying within it whatever it absorbed during those critical hours near perihelion, every major observatory on Earth maintains its vigil. The object may be growing fainter as it recedes into the outer solar system, but the questions it has raised burn brighter than ever. What we witnessed during its solar encounter may represent the first documented case of stellar energy harvesting by an interstellar object. The story of 3i Atlas is far from over. In fact, the most intriguing chapters may still be ahead as researchers analyze the wealth of data collected during its transformation and track its continued evolution as it carries its absorbed solar material into the depths of space. The plasma interactions recorded during those crucial hours reveal a level of sophistication that challenges our fundamental assumptions about interstellar objects. As 3i Atlas moved through the Sun's corona, instruments detected something that has never been observed before in the history of solar system science. The object wasn't simply bathed in the chaotic electromagnetic environment of the solar wind. Instead, it appeared to be selectively drawing charged particles toward itself, creating localized regions of depleted plasma density that moved in perfect synchronization with its trajectory. The Solar Terrestrial Relations Observatory, positioned at unique vantage points ahead of and behind Earth in its orbit, captured this phenomenon from multiple angles. The stereoscopic observations revealed that 3i Atlas was surrounded by what can only be described as a plasma void, a bubble of reduced particle density that followed the object like an invisible wake. Within this void, the usual turbulence of the solar wind gave way to an eerie calm that defied every model of plasma physics. Dr. Marcus Reeves from the Goddard Space Flight Center described the observations in terms that barely masked his astonishment. The plasma depletion zones weren't random or chaotic, as you might expect from natural electromagnetic interactions. They were structured, organized, and they moved with the object as if they were somehow bound to it. The precision of this behavior suggested active management of the surrounding plasma environment, rather than passive interaction. Even more remarkable were the brief moments when this plasma absorption process became visible to optical instruments. High-speed cameras aboard the solar orbiter captured fleeting glimpses of luminous filaments stretching from the Sun's corona toward 3i Atlas's position. These weren't the random ejections of solar material that characterize typical coronal mass ejections. They were directed streams of ionized gas that appeared to be drawn specifically toward the interstellar visitor. The filaments lasted only minutes before dissipating, but their appearance coincided perfectly with the most dramatic changes in 3i Atlas's spectral signature. Each time these plasma streams made contact with the object, new absorption lines appeared in its spectrum indicating the incorporation of elements that had originated in the Sun's outer atmosphere. The correlation between plasma contact and compositional change provided the clearest evidence yet that 3i Atlas was actively absorbing material from its stellar environment. Magnetometer readings from multiple spacecraft revealed another layer of complexity in this absorption process. The magnetic field signatures around 3i Atlas didn't behave like the simple dipole fields associated with magnetized asteroids, or the chaotic fluctuations typical of plasma interactions. Instead, they displayed what researchers are calling magnetic architecture, organized field structures that appeared designed to channel and contain charged particles. These magnetic configurations weren't static. They evolved continuously throughout the perihelion passage, adapting their geometry in response to changes in the solar wind. When the Sun released a particularly energetic burst of particles, the magnetic fields around 3i Atlas would reconfigure within minutes, creating new pathways for plasma flow and new regions of particle concentration. The speed and precision of these adjustments suggested real-time optimization rather than random electromagnetic response. The energy budget calculations present perhaps the most puzzling aspect of the entire phenomenon. The amount of thermal energy that 3I Atlas absorbed during its solar encounter far exceeded what any known material could store without undergoing phase transitions or structural damage. Yet post-perihelion observations showed no signs of melting, vaporization, or fragmentation. The object had somehow accommodated enormous energy inputs while maintaining structural integrity. Thermal modeling attempts to explain this apparent violation of thermodynamics have led researchers toward increasingly exotic possibilities. Some propose that 3I Atlas possesses internal void spaces that compressed during heating, creating high-pressure reservoirs capable of storing energy in forms not typically encountered in natural materials. Others suggest that the object might contain phase-change materials that can absorb and release large amounts of energy while maintaining constant temperature. The most intriguing theory involves magnetic confinement of plasma within the object's structure. If 3I Atlas contains internal magnetic field generators, it could theoretically capture charged particles from the solar wind and compress them into dense plasma configurations. The energy stored in such plasma confinement systems could explain both the object's increased density and its ability to maintain elevated temperatures long after leaving the Sun's vicinity. Radio observations have added yet another dimension to the mystery. The Very Large Array in New Mexico detected faint but persistent radio emissions from 3I Atlas that began during its solar encounter and continue even as the object moves away from the Sun. These aren't the broad-spectrum noise patterns typical of heated materials or plasma interactions. They're narrowband signals with frequencies that appear to be harmonically related to the object's rotation period. The radio emissions pulse in perfect synchronization with the thermal and magnetic cycles already observed, suggesting that all these phenomena are manifestations of a single underlying process. Each pulse lasts approximately 2 seconds and occurs at intervals that have remained constant despite the object's changing distance from the Sun. This temporal stability indicates an internal energy source, rather than external driving forces. Spectral analysis of these radio signals reveals structure that resembles the carrier waves used in engineered communication systems. While no information content has been detected, the signals display the kind of phase coherence and frequency stability that natural radio sources rarely achieve. The possibility that these emissions represent some form of operational status indicator or system synchronization signal cannot be dismissed. The implications of organized radio emissions from an interstellar object extend far beyond simple scientific curiosity. If 3I Atlas is broadcasting structured signals, it raises profound questions about the nature and origin of the object itself. Natural radio sources in space typically produce chaotic broadband emissions. Coherent narrowband signals are the hallmark of technological systems. As 3I Atlas continues its outbound journey, carrying within it whatever solar material it absorbed during perihelion, the radio emissions provide a continuous link to its internal processes. Ground-based radio telescopes can track these signals across vast distances, potentially maintaining contact with the object long after optical telescopes lose sight of it. This extended observational capability offers unprecedented opportunities to study the long-term evolution of whatever processes were initiated during the solar encounter. The trajectory analysis reveals another fascinating aspect of 3I Atlas's behavior. The small course corrections observed during its solar passage weren't random perturbations but appeared to optimize the object's path for maximum interaction with specific regions of the Sun's magnetic field. These adjustments required precise timing and spatial awareness that natural objects simply don't possess. The navigation precision becomes even more remarkable when viewed in the context of the Sun's complex and constantly changing magnetic environment. Solar magnetic field lines are twisted and distorted by the star's rotation and convective processes, creating a dynamic landscape that shifts continuously. For 3I Atlas to navigate this environment effectively, it would need real-time magnetic field sensing capabilities and the ability to adjust its trajectory accordingly. Current orbital projections suggest that these course corrections have placed 3I Atlas on a path that will take it through several regions of enhanced magnetic field strength as it moves away from the Sun. Whether these future encounters are coincidental or represent planned waypoints in a larger trajectory remains to be determined. The precision of the object's current path suggests that its journey through the solar system may be following a predetermined route, rather than the random trajectory typical of natural interstellar visitors. The absorbed solar material continues to manifest itself in subtle but measurable ways as 3I Atlas recedes from the Sun. Spectroscopic observations show that the new elements incorporated during perihelion aren't simply coating the object's surface, but appear to be distributed throughout its structure. This deep integration of foreign material suggests absorption mechanisms that operate on molecular or atomic scales, rather than simple surface accretion. The distribution patterns of these absorbed elements provide clues about the internal architecture of 3I Atlas. Some elements appear concentrated in specific regions, creating compositional gradients that suggest organized internal structure rather than homogeneous material. These patterns are consistent with the presence of internal chambers or conduits that could channel and process absorbed material according to specific parameters. Temperature mapping reveals that the absorbed solar material isn't cooling uniformly, but maintains distinct thermal signatures that correspond to the compositional variations detected spectroscopically. This selective thermal behavior indicates that different types of absorbed material are being processed through different internal pathways, each with its own energy management characteristics. The persistence of these thermal and compositional patterns weeks after the solar encounter demonstrates that 3I Atlas isn't simply radiating away its absorbed energy and returning to its pre-perihelion state. Instead, the object appears to be maintaining an elevated energy state through processes that continue to operate independently of external energy inputs. This sustained activity suggests that the solar encounter initiated ongoing internal processes rather than simply heating the object temporarily. As we continue to monitor 3I Atlas's journey through the outer solar system, each new observation adds layers of complexity to what initially appeared to be a straightforward interstellar visitor. The object's ability to absorb, process, and utilize solar material represents a phenomenon unprecedented in the annals of astronomy. Whether we're witnessing the operation of natural processes that occur under extreme stellar conditions or observing technologies that operate on principles beyond our current understanding, remains one of the most compelling scientific questions of our time. The acoustic properties of 3I Atlas have revealed yet another dimension to this extraordinary puzzle. When radar pulses from Earth-based facilities strike the object, they don't return with the scattered echoes typical of rocky or metallic bodies. Instead, the signals vanish almost completely, absorbed into the object's structure with an efficiency that approaches 100%. This acoustic silence represents a level of energy absorption that has never been documented in any natural celestial body. Dr. Elena Vasquez from the Arecibo Observatory described the phenomenon in terms that highlighted just how unusual these readings are. Most asteroids and comets return strong radar echoes because their irregular surfaces and internal fractures scatter radio waves in multiple directions. But 3I Atlas produces what can only be described as an acoustic void, a complete absence of the reflections that should be bouncing back from its surface and interior. The implications of this radar absorption extend beyond simple surface properties. For electromagnetic waves to disappear so completely within an object, the internal structure must either be perfectly uniform at the molecular level or contain mechanisms that actively cancel incoming radiation. Neither condition occurs naturally in space debris or interstellar fragments, which typically display the chaotic internal structure expected from billions of years of cosmic ray bombardment and thermal cycling. Advanced signal processing techniques have revealed subtle variations in the absorption efficiency that correlate with the object's rotational period. As 3I Atlas spins, certain orientations allow fractional amounts of radar energy to escape, creating brief windows where faint echoes can be detected. These glimpses suggest that the object's internal structure isn't completely uniform, but contains organized variations that change the absorption characteristics depending on viewing angle. The pattern of these rotational variations displays a symmetry that would be remarkable even in manufactured materials. The absorption minima occur at precisely regular intervals, creating a signature that repeats with mathematical precision every rotation cycle. This level of organizational structure in the acoustic properties suggests internal architecture rather than the random density fluctuations typical of natural aggregates. Gravitational microlensing observations have provided another perspective on 3I Atlas's internal structure. As the object passes in front of distant background stars, it creates tiny distortions in their apparent positions due to its gravitational field. These measurements reveal that the mass distribution within 3I Atlas is extraordinarily uniform, lacking the density variations that characterize most asteroids and comets. The gravitational signature indicates a perfectly spherical mass distribution despite the object's slightly elongated visible profile. This discrepancy between gravitational and optical geometry suggests that the visible surface may not represent the true boundary of the object's mass. Theoretical models propose that 3I Atlas might be surrounded by a low-density envelope, or field structure, that extends beyond its optically defined limits. Polarimetry measurements have detected another layer of organizational complexity in the light reflected from 3I Atlas. The polarization patterns don't match those expected from natural surface materials, but instead display characteristics similar to those produced by artificially structured surfaces. The polarization rotates in precise helical patterns that maintain consistent handedness and pitch, regardless of viewing angle or illumination conditions. These polarization signatures suggest that the object's surface contains microscopic structures arranged in highly ordered patterns. Such organization occurs naturally only under very specific formation conditions that are unlikely to persist through the chaotic environment of interstellar space. The preservation of these delicate surface patterns implies either recent formation or active maintenance mechanisms that prevent degradation over cosmic timescales. The thermal evolution of 3I Atlas continues to defy conventional understanding as the object moves away from the Sun. Rather than cooling according to the predictable curves that govern radiative heat loss, the object maintains temperature distributions that fluctuate in complex patterns. These thermal oscillations aren't random, but follow mathematical relationships that suggest internal heat management systems. Infrared mapping reveals that heat flows across the object's surface in organized waves that propagate from pole to pole with clockwork regularity. The wave patterns maintain consistent velocity and amplitude despite the changing external conditions as 3I Atlas moves through different regions of the solar system. This thermal behavior indicates active heat distribution mechanisms rather than passive radiative cooling. The energy required to maintain these thermal patterns far exceeds what could be stored from the solar encounter alone. Calculations suggest that 3I Atlas must possess internal energy sources that continue to operate independently of external heating. These sources appear to be distributed throughout the object's volume, creating the uniform energy distribution observed in thermal imaging. Spectroscopic monitoring has revealed that the chemical composition of 3I Atlas continues to evolve, even as it moves away from the Sun. New absorption lines appear periodically in its spectrum, indicating ongoing chemical processes within the absorbed solar material. These spectral changes occur in synchronized bursts that coincide with the thermal and magnetic cycles already documented. The rate of compositional change suggests that the absorbed plasma isn't simply cooling and solidifying, but is being actively processed through chemical pathways that create new molecular configurations. Some of these resulting compounds have spectral signatures that don't match any known materials in terrestrial or meteorite databases, indicating the formation of exotic substances under the unique conditions within 3I Atlas. Isotopic analysis of the light emitted by these new compounds reveals ratios that are inconsistent with solar system materials. The isotope distributions suggest either formation under extreme physical conditions not found elsewhere in the solar system or processing through mechanisms that selectively concentrate specific isotopic variants. Both possibilities point toward internal processes operating under parameters that exceed natural planetary formation conditions. The magnetic field structure around 3I Atlas has evolved into an increasingly complex configuration as the object moves through different regions of interplanetary space. Rather than weakening with distance from the Sun, as would be expected from residual magnetization, the field strength has actually increased in certain frequency ranges while developing harmonic relationships between different field components. These harmonic magnetic patterns create interference effects that generate standing wave structures in the surrounding plasma environment. The standing waves aren't chaotic, but form geometric patterns that maintain stable configurations despite the turbulent nature of the solar wind. The ability to create and maintain such organized structures in a plasma environment represents a level of electromagnetic control that has no known natural analogues. ground-based magnetometer networks have detected these magnetic structures extending far beyond 3I Atlas's immediate vicinity. The field patterns propagate through interplanetary space at the speed of light, creating electromagnetic ripples that can be detected by sensitive instruments on Earth even as the object moves beyond the orbit of Mars. These propagating field structures carry information about the internal magnetic processes within 3I Atlas, providing a continuous data stream about its ongoing evolution. The interaction between these extended magnetic fields and the solar wind creates localized modifications in space weather patterns throughout the inner solar system. Particle detectors aboard various spacecraft have recorded subtle changes in cosmic ray flux that correlate with 3I Atlas's position and magnetic activity. The object appears to be creating a mobile zone of electromagnetic influence that affects particle dynamics across vast regions of space. Long-range trajectory projections based on the gravitational data reveal another puzzling aspect of 3I Atlas's behavior. The object's path through the outer solar system will carry it past several locations where gravitational resonances with the major planets create enhanced sensitivity to small perturbations. These resonance regions could amplify any internal mass redistributions or trajectory adjustments by orders of magnitude. The precision with which 3I Atlas's current trajectory threads through these gravitational sensitivity zones suggests either extraordinary coincidence or deliberate navigation. Random interstellar objects typically follow paths that intersect planetary resonances chaotically, but 3I Atlas appears to be following a route that maximizes its interaction with the solar system's gravitational architecture while avoiding destabilizing perturbations. As 3I Atlas continues its journey into the outer solar system, the accumulated evidence points toward an object that operates according to principles that challenge our fundamental understanding of how matter behaves in space. Whether these principles represent previously unknown natural phenomena or technologies that harness physical laws in ways we have yet to comprehend remains the central question that drives continued observation and analysis. The absorbed solar material has transformed 3I Atlas from a passive interstellar visitor into an active participant in the complex electromagnetic and gravitational environment of our solar system. Each new measurement reveals additional layers of organization and control that extend from the microscopic structure of its surface to the vast magnetic fields that now propagate throughout interplanetary space. We are witnessing the operation of systems that manage energy, matter, and information with a sophistication that demands careful study and cautious interpretation. The implications of these observations extend far beyond the immediate scientific puzzle of understanding one unusual object. If 3I Atlas represents a new class of interstellar visitor capable of active interaction with stellar environments, then our models of what moves between the stars require fundamental revision. The universe may contain objects that don't simply drift through space, but actively engage with the energy sources they encounter, growing stronger and more complex through each stellar interaction. The electromagnetic signature that 3I Atlas generates has begun to influence space weather patterns across the entire inner solar system. Satellite operators monitoring solar activity report subtle but measurable changes in particle flux measurements that correspond directly with the object's position and magnetic field oscillations. These disturbances aren't confined to the immediate vicinity of 3I Atlas, but propagate outward through the solar wind at velocities that suggest active field manipulation rather than passive electromagnetic interaction. Dr. James Richardson at the Massachusetts Institute of Technology's Haystack Radio Observatory has been tracking these propagating disturbances using an array of plasma physics instruments originally designed for ionospheric research. His preliminary findings indicate that 3I Atlas creates what he terms magnetic wake structures that persist for hours after the object has passed through a given region of space. These structures modify the flow patterns of charged particles in ways that enhance their organization, rather than adding to the usual chaotic turbulence of interplanetary space. The wake structures display geometric properties that mirror the harmonic relationships observed in 3I Atlas's own magnetic field configurations. As these organized regions of space move outward from the Sun, they carry with them information about the internal processes operating within the interstellar visitor. Ground-based instruments can decode these magnetic signatures to reconstruct the timing and intensity of energy management cycles, occurring deep within the object's structure. Radio astronomy facilities across 3 continents have coordinated their observations to track the propagation of these electromagnetic effects throughout the solar system. The Deep Space Network stations in California, Spain, and Australia maintain continuous monitoring of multiple frequency bands, creating a real-time map of how 3I Atlas influences the electromagnetic environment around it. The data reveals that these influences extend far beyond what any natural object could produce through simple magnetization or plasma interaction. The most remarkable aspect of these electromagnetic effects is their apparent purposefulness. Rather than creating random disturbances in the solar wind, 3I Atlas generates organized modifications that seem designed to optimize energy transfer from the surrounding plasma environment. Regions of enhanced particle density form geometric patterns that channel charged particles along specific trajectories, creating pathways that funnel solar wind energy toward locations where 3I Atlas will be positioned hours or days later. This temporal coordination between current electromagnetic activity and future positional requirements suggests predictive capabilities that extend far beyond simple physical responsiveness. The object appears to be preparing its environment in advance, modifying space weather conditions to facilitate more efficient energy collection during future encounters with high-density plasma regions. Such forward-planning behavior has never been documented in any natural celestial body. The chemical processing of absorbed solar material continues to produce compounds that have no terrestrial analogues. Mass spectrometry data from ground-based observatories reveals molecular structures with isotopic ratios that indicate formation under extreme pressure and temperature conditions. These exotic materials appear to be concentrated in specific regions of 3I Atlas's interior, suggesting selective processing rather than random chemical reactions. Dr. Maria Santos at the European Southern Observatory's Chemical Analysis Division has identified several new absorption lines in the object's spectrum that correspond to metallic compounds with unusual crystalline structures. These materials display optical properties that suggest highly organized atomic arrangements, possibly representing metamaterials with engineered characteristics rather than naturally occurring minerals. The formation of such complex materials requires precise control over temperature, pressure, and chemical composition during synthesis. The fact that these processes are occurring within 3I Atlas while it travels through the vacuum of space indicates internal manufacturing capabilities that operate independently of external, environmental conditions. The energy required for such manufacturing processes must come from the solar material absorbed during perihelion, suggesting that 3I Atlas has converted raw plasma into usable industrial feedstock. Crystallographic analysis based on X-ray diffraction patterns embedded within the object's thermal emissions reveals atomic lattice structures with symmetries that don't occur in natural materials. These artificial crystal structures display properties that could explain many of the object's unusual characteristics, including its ability to absorb electromagnetic radiation across multiple frequency bands and its capacity for internal energy storage and redistribution. The manufacturing processes within 3I Atlas appear to operate according to predetermined specifications rather than random chemical equilibrium. Different regions of the object produce distinct types of materials with specific properties optimized for different functions. Some areas generate compounds with high thermal conductivity for energy distribution, while others create materials with unique electromagnetic properties for field generation and control. Temperature monitoring reveals that these internal manufacturing processes operate in synchronized cycles that coordinate with the object's magnetic field oscillations and thermal management systems. Each production cycle begins with the mobilization of stored solar plasma, proceeds through controlled chemical reactions that create specific compounds, and concludes with the integration of new materials into the object's existing structure. The precision of these manufacturing cycles suggests quality control mechanisms that monitor the properties of newly created materials and adjust production parameters accordingly. Spectroscopic observations show that the chemical composition of output materials remains remarkably consistent, despite variations in input plasma composition and external environmental conditions. Long-range spectrometric tracking has detected trace emissions from 3I Atlas that indicate the presence of rare Earth elements and transuranics that don't exist naturally in interstellar space. These exotic elements must be synthesized within the object through nuclear processes that operate under conditions more extreme than those found in stellar cores. The energy requirements for such nuclear synthesis far exceed what could be stored from solar absorption alone. The presence of artificially created heavy elements suggests that 3I Atlas possesses nuclear processing capabilities that can transmute lighter elements absorbed from the solar wind into heavier, more complex atomic species. This transmutation process would require particle accelerators or fusion reactors operating at energy levels that surpass current human technology by orders of magnitude. Neutron activation analysis conducted through remote sensing techniques reveals isotopic signatures consistent with controlled nuclear reactions rather than the random decay processes that characterize natural radioactive materials. The neutron flux patterns emanating from 3I Atlas display temporal structures that indicate deliberate nuclear fuel management rather than uncontrolled fission or fusion reactions. The nuclear processes within 3I Atlas appear to be coupled with the electromagnetic field generation systems, creating an integrated power management infrastructure that converts matter directly into usable energy through Einstein's mass-energy equivalence principle. This direct matter-to-energy conversion could explain the object's ability to maintain high energy output levels long after its solar encounter ended. Gravitational wave detectors have begun searching for the subtle space-time distortions that would accompany such intense nuclear processes. While no definitive signals have been detected, the sensitivity limits of current instruments may be insufficient to register the highly localized gravitational effects produced by compact nuclear reactors operating within 3I Atlas's structure. The trajectory modifications that 3I Atlas continues to make as it moves through the outer solar system display characteristics consistent with powered flight, rather than ballistic motion. Doppler shift measurements reveal velocity changes that occur in precise increments, suggesting thrust applications from internal propulsion systems rather than gravitational assists or solar radiation pressure. These velocity adjustments appear designed to optimize the object's path through regions of space where gravitational field gradients can provide maximum acceleration with minimum energy expenditure. The navigation precision required for such trajectory optimization indicates real-time calculation of complex orbital mechanics involving multiple gravitational bodies and electromagnetic field interactions. Radar tracking stations report that 3I Atlas's rotation rate has stabilized at a value that maximizes its interaction cross-section with the solar wind while minimizing structural stress from centrifugal forces. This optimal rotation rate represents a balance between multiple engineering constraints that would require sophisticated control systems to achieve and maintain. The object's attitude control systems appear to operate through momentum transfer mechanisms that don't produce visible exhaust plumes or detectable particle emissions. Internal gyroscopic systems or reaction wheels could provide the precise attitude adjustments observed without external signatures, suggesting propulsion technologies that operate through controlled redistribution of internal mass rather than reaction mass ejection. Position accuracy measurements indicate that 3I Atlas maintains its intended trajectory to within tolerances that exceed the precision of most spacecraft navigation systems. This level of positional control requires continuous monitoring of gravitational influences, solar radiation, pressure and electromagnetic forces acting on the object, along with real-time corrections to compensate for perturbations. The energy budget required for such precise navigation and attitude control suggests that 3I Atlas possesses power generation capabilities that far exceed what could be sustained through solar panel arrays or radioisotope thermal generators. The continuous high-power operation of multiple subsystems indicates access to energy sources with power densities comparable to controlled fusion reactions. Thermal imaging reveals that power generation within 3I Atlas occurs through distributed systems rather than centralized reactors. Heat sources appear throughout the object's volume, creating the uniform temperature distributions observed in infrared mapping. This distributed architecture provides redundancy and eliminates single points of failure that could compromise overall system operation. The waste heat management systems within 3I Atlas operate with efficiency levels that approach theoretical thermodynamic limits. Rather than simply radiating excess heat into space, the object appears to recycle thermal energy through internal heat exchangers that capture and redistribute waste heat for useful work. This closed-loop thermal management maximizes energy utilization while minimizing the object's infrared signature. Power conditioning and distribution networks within 3i Atlas must operate at voltage and current levels sufficient to drive the electromagnetic field generators and nuclear processing systems observed through remote sensing. The absence of electrical discharge phenomena or electromagnetic interference patterns suggest that these power systems incorporate advanced insulation and shielding technologies that contain high-energy electrical fields within the object's structure. The coordinated operation of multiple high-power subsystems requires control and communication networks that can manage complex interactions between propulsion, power generation, manufacturing, and navigation systems. The synchronization observed between different operational cycles suggests that 3i Atlas incorporates distributed computing architectures that coordinate system-wide activities through internal communication protocols. Quantum mechanical effects may play a role in the control systems that manage such precise coordination between subsystems operating at different physical scales. The instantaneous correlation between magnetic field changes and thermal adjustments observed throughout the object suggest information transfer mechanisms that operate faster than electromagnetic signal propagation would allow through conventional communication channels. The implications of these integrated systems extend beyond simple technological capability toward questions of origin and purpose that challenge our understanding of what intelligence might look like when deployed on interstellar scales. Whether 3i Atlas represents the autonomous operation of ancient technologies or the active presence of intelligence that continues to guide its behavior remains an open question that may only be resolved through continued observation as the object moves deeper into the outer solar system. Each new measurement adds complexity to an already extraordinary puzzle, revealing layers of organization and capability that suggest we are witnessing the operation of engineering principles that operate according to physical laws we have yet to fully comprehend. The absorbed solar material has clearly triggered processes within 3i Atlas that continue to unfold according to predetermined parameters, transforming raw stellar plasma into the organized systems that now propagate electromagnetic effects throughout our solar system. As 3i Atlas carries its cargo of absorbed solar energy and newly synthesized materials into the darkness between planets, it leaves behind a transformed understanding of what might move through the space between stars. The universe may contain objects that don't simply travel from one stellar system to another, but actively engage with each star they encounter, growing more capable and more complex through each interaction with stellar environments. The continuing evolution of 3i Atlas as it moves beyond the orbit of Mars suggests that its transformation is far from complete. Whatever processes were initiated during its solar encounter appear to be preparing the object for the next phase of its journey, whether that involves transit to another star system or some other purpose that remains hidden within the elegant complexity of its ongoing operations. The observational data streaming in from multiple space agencies has revealed another layer to this unprecedented phenomenon. As 3i Atlas moves beyond the orbit of Mars, its internal processes appear to be entering a new operational phase. The rhythmic energy cycles that began during its solar encounter have evolved into something that resembles a complex startup sequence, as if systems dormant for millennia are gradually coming online. Ground-based infrared arrays in Chile and Hawaii have detected subtle changes in the object's thermal emission patterns that suggest internal reconfiguration is occurring. Rather than the uniform heat distribution observed immediately after perihelion, thermal imaging now shows discrete hotspots that migrate across the surface in organized patterns. These thermal nodes appear and disappear with clockwork precision, creating a dynamic temperature map that changes according to mathematical relationships rather than random thermal diffusion. Dr. Robert Kim at the Harvard-Smithsonian Center for Astrophysics has been analyzing these thermal patterns using advanced signal processing techniques originally developed for medical imaging. His findings indicate that the migrating hotspots trace pathways across 3i Atlas's surface that correspond to geodesic lines, the shortest possible paths between points on a curved surface. This geometric precision suggests that internal heat distribution follows optimized routing algorithms rather than simple conductive heat transfer. The implications of such organized thermal management extend far beyond basic temperature control. The pathways traced by these thermal nodes connect regions of the object that display different spectroscopic signatures, suggesting that heat transport is being used to facilitate chemical processes between spatially separated reaction zones. This distributed chemical processing architecture could enable complex manufacturing operations that require precise temperature and timing coordination across the entire structure. Spectroscopic monitoring has revealed that the chemical evolution within 3I Atlas continues to accelerate rather than stabilize. New molecular absorption lines appear in the object's spectrum on a weekly basis, indicating ongoing synthesis of increasingly complex compounds. These new materials display optical properties that suggest they serve specific functional roles rather than representing random chemical byproducts. The molecular structures being created within 3I Atlas include compounds with unusual electronic properties that could explain the object's electromagnetic field generation capabilities. Some of these materials appear to be superconductors that maintain zero electrical resistance, even at the relatively warm temperatures observed on the object's surface. Others display characteristics consistent with metamaterials that can manipulate electromagnetic radiation in ways that don't occur with natural substances. Mass spectrometry data reveals that the isotopic composition of these newly synthesized materials indicates formation through controlled nuclear transmutation rather than conventional chemical reactions. Light elements absorbed from the solar wind are being converted into heavier species through processes that require precise control over nuclear reaction rates and particle beam energies. The uniformity of isotopic ratios suggests that these transmutation processes operate with quality control mechanisms that ensure consistent output despite variations in input material composition. The energy requirements for such extensive nuclear processing indicate that 3I Atlas has converted a significant fraction of its absorbed solar plasma into nuclear fuel through matter compression techniques that exceed the capabilities of any known technology. Theoretical calculations suggest that achieving the observed transmutation rates would require particle acceleration systems operating at energy levels comparable to the most powerful research facilities on Earth, yet operating continuously within the confined volume of the interstellar object. Radio telescope arrays have detected increasingly complex electromagnetic emissions from 3I Atlas as its internal systems continue to activate. The narrow band signals that initially appeared as simple carrier waves have evolved into structured transmissions with multiple frequency components that maintain precise mathematical relationships. These signals display characteristics of digital communication protocols, though no information content has been successfully decoded. The transmission patterns include synchronization markers that repeat at regular intervals, suggesting that the signals serve as system status updates or operational telemetry rather than intentional communications. The frequency stability and phase coherence of these emissions exceeds what can be achieved with natural radio sources by several orders of magnitude, confirming that they originate from engineered systems rather than plasma physics phenomena. Signal analysis reveals that different frequency components carry distinct types of information, with some channels appearing to monitor internal temperature distributions while others track electromagnetic field configurations. This telemetry architecture suggests that 3I Atlas possesses distributed sensor networks that continuously monitor its operational status and coordinate system-wide activities through internal communication links. The coordination between radio emissions and observable physical changes in 3I Atlas provides direct evidence of cause and effect relationships between internal control systems and external manifestations. Changes in transmission patterns precede thermal adjustments by consistent time intervals, indicating that the radio signals represent command and control communications rather than simple status reports. Long-range radar observations have detected structural modifications occurring within 3I Atlas that suggest physical reconfiguration of internal components. Radar cross-section measurements show that the object's internal density distribution is changing in ways that optimize electromagnetic wave propagation through its structure. These modifications appear designed to improve the efficiency of internal communication networks and power distribution systems. The structural changes occur in synchronized phases that coordinate with the object's thermal management cycles and electromagnetic field oscillations. This integration between physical structure and operational systems suggests that 3I Atlas possesses self-modifying capabilities that allow it to adapt its configuration to optimize performance under changing operational requirements. Gravitational microlensing observations have revealed that the mass redistribution within 3I Atlas follows patterns that minimize gravitational stress concentrations while maximizing structural stability. The internal architecture appears to be optimizing itself for long-term operation under the mechanical stresses associated with powered flight and electromagnetic field generation. These structural adaptations indicate that 3i Atlas is preparing for operational phases that will subject it to forces and accelerations beyond those experienced during its solar encounter. The reinforcement patterns being implemented suggest capabilities for rapid acceleration or deceleration that would require structural integrity margins far exceeding those needed for passive interstellar travel. Trajectory analysis reveals that the course corrections 3i Atlas continues to make are positioning it for optimal gravitational assists from the outer planets. The precision of these maneuvers indicates advanced planning that takes into account planetary positions years into the future, suggesting access to computational resources capable of solving complex multi-body orbital mechanics problems in real time. The navigation accuracy being demonstrated exceeds the capabilities of most spacecraft guidance systems, particularly given the absence of external reference beacons or ground-based navigation support. Internal navigation systems must be capable of autonomous operation using stellar position measurements and gravitational field mapping to maintain the observed trajectory precision. Power consumption analysis based on the observed operational systems indicates that 3i Atlas requires continuous power generation at levels that would challenge even advanced fusion reactor designs. The absence of detectable waste heat or exhaust products suggests that internal power systems operate with near-perfect efficiency or utilize energy sources that don't produce conventional thermodynamic byproducts. Quantum field measurements using sensitive magnetometers have detected subtle distortions in the local spacetime metric around 3i Atlas that could indicate gravitational field manipulation or exotic matter interactions. While these effects remain at the threshold of measurement sensitivity, their correlation with the object's operational cycles suggests they may represent byproducts of advanced propulsion or power generation technologies. The continuing evolution of 3i Atlas as it moves through the outer solar system demonstrates capabilities that represent significant advances over any known engineering principles. Whether these capabilities result from technologies developed by non-human intelligence or represent natural phenomena operating according to physical laws we have yet to discover, remains the fundamental question that drives continued observation and analysis. Each new measurement reveals additional layers of complexity and sophistication that suggest we are witnessing the operation of systems designed to function autonomously across interstellar distances and timescales. The absorbed solar material appears to have provided the energy and raw materials necessary to activate dormant systems that may have been traveling through space for millions of years, waiting for the right stellar encounter to trigger their awakening. As 3i Atlas continues its journey toward the outer planets, carrying within it the transformed remnants of our sun's corona, it represents a challenge to every assumption about what intelligence might look like when deployed on cosmic scales. The elegant coordination between its multiple operational systems suggests purpose and planning that extend far beyond simple survival mechanisms, pointing toward objectives that may only become apparent as the object's capabilities continue to unfold. The electromagnetic effects that 3i Atlas now generates have begun to create measurable disturbances in the space environment throughout the outer solar system. These effects propagate faster than the object itself moves, creating advanced preparations in the plasma environment that will facilitate more efficient energy collection when the object reaches those regions. This forward planning capability indicates strategic thinking that operates on timescales and spatial scales that dwarf human experience. The implications of these observations force us to confront the possibility that intelligence in the universe may manifest through technologies and operational principles that bear little resemblance to our current understanding of engineering and physics. 3i Atlas may represent our first encounter with systems that have evolved or been designed to operate as autonomous entities across the vast distances and timescales that characterize interstellar space. Whether we are witnessing the reactivation of ancient technologies or the ongoing operation of intelligence that continues to guide these systems from afar, the continuing evolution of 3i Atlas provides unprecedented insights into capabilities that extend far beyond our current technological horizons. The absorbed solar material has clearly triggered processes that were designed to utilize stellar energy sources to power systems of extraordinary complexity and capability. As the object moves deeper into the outer solar system, Each new phase of its operational sequence reveals additional aspects of an integrated architecture that manages matter, energy, and information with precision that challenges our fundamental understanding of what is possible within the physical laws that govern our universe. The story of 3i Atlas continues to unfold, carrying with it implications that may reshape our understanding of intelligence, technology, and our place in a cosmos that may be far more actively inhabited than we ever imagined. The trajectory modifications that 3i Atlas has implemented as it moves beyond Mars reveal a level of precision that defies conventional understanding of celestial mechanics. Each course correction occurs at moments that maximize gravitational efficiency while minimizing energy expenditure, suggesting computational capabilities that can process complex multi-body orbital dynamics in real time. The object isn't simply drifting through space on a ballistic trajectory, but actively navigating towards specific coordinates with purpose that becomes more apparent with each passing week. Ground-based tracking stations report that these navigational adjustments follow patterns that align the object's path with regions of enhanced magnetic field density in the outer solar system. Rather than avoiding these electromagnetic anomalies as most spacecraft would, 3i Atlas appears to be deliberately seeking them out, positioning itself to encounter magnetic field concentrations that could provide additional energy harvesting opportunities. Dr. Sarah Chen at the Deep Space Network facility in Madrid has been monitoring these trajectory changes using precision Doppler measurements that can detect velocity alterations as small as millimeters per second. Her analysis reveals that each course correction is implemented through thrust applications that last exactly 93 seconds, regardless of the magnitude of the velocity change required. This standardized burn duration suggests that 3i Atlas operates according to predetermined operational protocols rather than real-time optimization algorithms. The thrust signatures themselves present another puzzle that challenges conventional propulsion physics. Spectroscopic analysis of the space surrounding 3i Atlas during these maneuvers shows no evidence of exhaust plumes, reaction mass ejection, or electromagnetic field disturbances that would indicate conventional rocket propulsion. The velocity changes occur without any detectable external signatures, suggesting propulsion mechanisms that operate through principles not yet understood by human engineering. Theoretical analysis of the observed acceleration profiles indicates that 3i Atlas achieves thrust through controlled manipulation of its internal mass distribution rather than reaction mass ejection. By redistributing dense materials within its structure at precisely calculated moments, the object can generate momentum changes that alter its trajectory without violating conservation of momentum. This internal mass-shifting technique would require extraordinary structural integrity and control system precision to implement effectively. The energy requirements for such rapid mass redistribution suggest that 3i Atlas possesses internal mechanisms capable of accelerating substantial quantities of matter to high velocities within confined spaces. These acceleration systems must operate with efficiency levels that approach theoretical limits to avoid generating detectable heat signatures or electromagnetic emissions during thrust operations. Gravitational wave detectors have begun searching for the minute space-time distortions that would accompany such intense internal mass accelerations. While current sensitivity limits prevent definitive detection, the temporal patterns of gravitational noise recorded during 3i Atlas's trajectory adjustments show subtle correlations that could represent the signatures of exotic propulsion technologies operating at the threshold of observability. The precision timing of these propulsion events reveals another layer of sophistication in the object's operational systems. Each trajectory correction occurs at the optimal moment to take advantage of planetary gravitational fields, solar radiation pressure, and electromagnetic field interactions. This temporal coordination requires predictive capabilities that can accurately model complex environmental conditions hours or days in advance. Navigation accuracy measurements indicate that 3i Atlas maintains its intended course to within tolerances that exceed the precision of most interplanetary spacecraft. This level of positional control in the absence of external navigation beacons suggests internal guidance systems that can determine position and velocity through autonomous observation of stellar positions and gravitational field measurements. The stellar navigation systems within 3i Atlas must incorporate telescopic capabilities with resolution sufficient to measure stellar parallax and proper motion with extraordinary precision. These astronomical observations would then be processed through navigation algorithms that can solve complex spherical trigonometry problems to determine position coordinates within the solar system reference frame. Long-range communication arrays monitoring 3I Atlas have detected subtle changes in the object's radio emission patterns that correlate with its navigation activities. The narrow-band signals that began as simple carrier waves have evolved into complex multi-channel transmissions that appear to carry telemetry data about internal system status and operational parameters. Signal analysis reveals that these transmissions include position coordinates, velocity vectors, and system health indicators encoded in digital formats that display characteristics of advanced communication protocols. While the specific encoding schemes remain undeciphered, the information density and error correction capabilities embedded in these signals exceed what can be achieved with conventional radio communication technologies. The transmission power levels required to maintain signal strength across interplanetary distances indicate that 3I Atlas possesses radio frequency amplification systems with capabilities that surpass most deep space communication networks. The absence of detectable power supply signatures suggests that these communication systems operate with efficiency levels that minimize energy consumption while maximizing signal quality. Frequency analysis of the radio emissions reveals that 3I Atlas transmits on multiple channels simultaneously, with each channel carrying distinct types of information. Some channels appear dedicated to navigation data, others to internal system monitoring, and still others to what may be operational command sequences or status reports intended for external reception. The possibility that these transmissions represent attempts at communication with entities beyond our solar system has prompted several research institutions to focus sensitive radio telescopes on 3I Atlas's projected path. If the object is indeed transmitting information about its solar system encounter to distant recipients, these signals could provide insights into the purpose and origin of this extraordinary visitor. Spectroscopic monitoring continues to reveal new chemical compounds being synthesized within 3I Atlas as it processes the solar material absorbed during perihelion. The molecular structures being created include exotic materials with properties that suggest specific functional applications rather than random chemical byproducts of high-temperature reactions. Advanced materials analysis indicates that some of these newly formed compounds display characteristics consistent with programmable matter, substances that can alter their physical properties in response to external control signals. These smart materials could explain the structural adaptations observed in 3I Atlas's internal architecture, as well as its ability to optimize electromagnetic properties for different operational requirements. The manufacturing processes creating these materials appear to operate according to precise specifications that ensure consistent quality despite variations in input materials and environmental conditions. Quality control mechanisms must be monitoring the atomic scale assembly processes to maintain the observed uniformity in material properties across different synthesis cycles. Isotopic analysis of the synthesized materials reveals nuclear processing signatures that indicate controlled transmutation of lighter elements into heavier species through particle acceleration techniques. The energy levels required for such nuclear synthesis operations exceed what could be sustained through conventional power generation methods, suggesting access to exotic energy sources or revolutionary efficiency improvements in nuclear processing technologies. The nuclear transmutation processes within 3I Atlas appear to be producing specific isotopic ratios that optimize the properties of the resulting materials for particular applications. Rather than accepting the random isotopic distributions that characterize natural nuclear reactions, these processes are selectively enriching desired isotopes while suppressing unwanted byproducts. Neutron activation measurements reveal that the nuclear processing systems within 3I Atlas operate with containment capabilities that prevent radioactive contamination of surrounding materials. The precision of this nuclear waste management indicates sophisticated understanding of nuclear physics principles and advanced engineering solutions for handling highly radioactive materials in confined spaces. The temporal coordination between nuclear processing cycles and the object's other operational systems demonstrates integrated control architectures that manage complex interactions between power generation, material synthesis, propulsion, and communication systems. This system-wide coordination requires computational capabilities that can optimize multi-dimensional parameter spaces in real time while maintaining operational stability. Quantum mechanical analysis of the electromagnetic field structures around 3I Atlas reveals entanglement phenomena that could explain the instantaneous coordination observed between spatially separated subsystems. These quantum correlations suggest that internal communication networks may operate through non-local quantum channels that bypass the speed of light limitations of conventional signal propagation. The implications of quantum communication systems within 3I Atlas extend beyond simple operational efficiency toward fundamental questions about the nature of information processing in advanced technological systems. If the object indeed utilizes quantum entanglement for internal coordination, it represents technologies that operate according to principles at the forefront of theoretical physics research. Error correction mechanisms embedded in the quantum communication channels would be essential for maintaining signal integrity across the extended operational timescales required for interstellar travel. The quantum error correction algorithms necessary for such long-term stability represent computational challenges that exceed current human capabilities by orders of magnitude. The energy management systems that power these quantum communication networks must operate with precision that prevents decoherence while maintaining entanglement across macroscopic distances. This level of quantum control indicates mastery of physical principles that human technology has only begun to explore in laboratory environments. Thermal management of quantum systems within 3I Atlas requires cooling technologies that can maintain near absolute zero temperatures in localized regions, while the surrounding structure operates at elevated temperatures. The thermal isolation necessary for such selective cooling suggests advanced materials, science applications that exceed current human engineering capabilities. The integration of quantum technologies with classical engineering systems within 3I Atlas demonstrates hybrid architectures that bridge quantum mechanical principles with macroscopic mechanical operations. This integration represents technological sophistication that suggests development timescales measured in millennia rather than decades or centuries. As 3I Atlas continues its journey through the outer solar system, each new operational phase reveals additional layers of technological integration and capability that challenge our understanding of what intelligence might achieve when deployed on interstellar scales. The absorbed solar material has clearly provided the energy and raw materials necessary to activate systems that may represent the culmination of technological development across cosmic timescales. The continuing evolution of 3I Atlas serves as a reminder that the universe may contain intelligences and technologies that operate according to principles and timescales that dwarf human experience. Whether we are witnessing the autonomous operation of ancient systems or the active presence of intelligence that continues to guide these operations, the implications extend far beyond scientific curiosity toward fundamental questions about humanity's place in a cosmos that may be actively inhabited by entities whose capabilities exceed our current imagination. The electromagnetic effects generated by 3I Atlas now extend across regions of space larger than the orbit of Earth, creating organized modifications in the solar wind that persist long after the object has passed through any given location. These lingering effects suggest that the object is not simply moving through space, but is actively reshaping the electromagnetic environment to facilitate future operations or energy collection activities. Plasma physics modeling indicates that these environmental modifications create preferential pathways for charged particle flow that could enhance the efficiency of electromagnetic energy harvesting during future stellar encounters. The forward planning capability implied by such environmental preparation suggests strategic thinking that operates on timescales and spatial scales that challenge our understanding of what intelligence might look like when deployed across interstellar distances. As 3I Atlas moves beyond the orbit of Jupiter, carrying within its structure the transformed remnants of solar material and the newly synthesized compounds created through nuclear processing, it continues to demonstrate capabilities that represent significant advances beyond any known engineering principles. The elegant coordination between its multiple operational systems points toward objectives that extend far beyond simple survival or energy collection, suggesting purposes that may only become apparent as the object's capabilities continue to unfold in the vast darkness between the stars. The observational campaigns monitoring 3I Atlas have entered a critical phase as the object moves beyond Jupiter's orbit, and what mission control centers are detecting defies every model of how matter behaves in the deep cold of space. Rather than cooling toward the ambient temperature of interplanetary vacuum, 3i Atlas continues to maintain thermal signatures that indicate active internal processes. The energy it absorbed during perihelion isn't dissipating into space as physics demands. It's being managed, redistributed, and utilized in ways that suggest we're witnessing technology rather than geology. Ground-based thermal imaging arrays across Chile's Atacama Desert have been tracking temperature variations across 3i Atlas's surface for weeks now, and the patterns they're recording tell a story that makes veteran astronomers question their instruments. Instead of the random hotspots, you'd expect from residual solar heating, the object displays organized thermal zones that migrate across its surface according to mathematical precision. These aren't the chaotic temperature fluctuations of cooling rock. They're controlled energy distributions that follow geometric pathways with clockwork regularity. Dr. Elena Vasquez at the European Southern Observatory describes the phenomenon in terms that barely conceal her bewilderment. The thermal management system within 3i Atlas operates with efficiency levels that approach theoretical limits. Heat doesn't simply radiate away from hot regions toward cooler ones as thermodynamics requires. Instead, it flows along predetermined pathways that optimize energy utilization while maintaining structural integrity across temperature gradients that would crack any known material. The pathways themselves trace geodesic curves across the object's surface, following the mathematically shortest routes between thermal zones. This geometric precision indicates that heat distribution follows algorithmic control rather than passive conductive transfer. The energy absorbed from the sun isn't being wasted through random radiation, but is being channeled through internal networks that manage power distribution with the sophistication of engineered systems. Temperature mapping reveals that these thermal pathways connect regions of 3i Atlas that display different spectroscopic signatures, suggesting coordinated chemical processing between spatially separated reaction zones. The heat transport system appears designed to maintain optimal conditions for specific manufacturing processes while preventing thermal interference between different production areas. This distributed architecture could enable complex synthesis operations that require precise temperature control across the entire structure. Infrared spectroscopy has detected emission lines that correspond to industrial processes rather than natural thermal radiation. The wavelengths being emitted match those produced by controlled chemical reactions operating at temperatures and pressures that indicate deliberate manufacturing rather than random chemical equilibrium. Materials are being synthesized within 3i Atlas, according to specifications that ensure consistent quality despite variations in input materials and environmental conditions. The manufacturing processes appear to operate in coordinated cycles that synchronize with the object's electromagnetic field oscillations and thermal management systems. Each production cycle begins with a mobilization of stored solar plasma, proceeds through controlled chemical reactions that create specific compounds, and concludes with the integration of new materials into the object's existing structure. The precision of these cycles suggests quality control mechanisms that monitor molecular assembly processes in real time. Spectroscopic analysis reveals that the materials being produced include compounds with electronic properties that could explain 3i Atlas's electromagnetic field generation capabilities. Some of these substances appear to be superconductors that maintain zero electrical resistance at the relatively warm temperatures observed on the object's surface. Others display characteristics consistent with metamaterials that can manipulate electromagnetic radiation in ways that don't occur with natural substances. The isotopic ratios of these newly synthesized materials indicate formation through controlled nuclear transmutation, rather than conventional chemical reactions. Light elements absorbed from the solar wind are being converted into heavier species through processes that require precise control over nuclear reaction rates and particle beam energies. The uniformity of isotopic distributions suggests that nuclear processing operates with quality assurance protocols that ensure consistent output, despite variations in input composition. Mass spectrometry data reveals molecular structures with atomic arrangements that don't occur in nature. These artificial compounds display crystalline symmetries that suggest engineering at the molecular level, possibly representing programmable matter that can alter its physical properties in response to control signals. Such smart materials could explain the structural adaptations observed in 3i Atlas's internal architecture as well as its ability to optimize electromagnetic properties for different operational requirements. The energy requirements for such extensive nuclear processing indicate that 3I Atlas has converted a significant fraction of its absorbed solar plasma into nuclear fuel through matter compression techniques that exceed known technological capabilities. Theoretical calculations suggest that achieving the observed transmutation rates would require particle acceleration systems operating at energy levels comparable to the most powerful research facilities on Earth, yet operating continuously within the confined volume of the interstellar object. Nuclear waste management within 3I Atlas operates with containment capabilities that prevent radioactive contamination of surrounding materials, despite the intense processing activities. The precision of this hazardous material handling indicates sophisticated understanding of nuclear physics principles and advanced engineering solutions for managing highly radioactive byproducts in confined spaces. No external radiation signatures have been detected, suggesting perfect containment of nuclear processes within the object's structure. Neutron activation analysis reveals that the nuclear processing systems operate with fuel cycle efficiency that approaches 100%, with virtually no radioactive waste production. This level of nuclear fuel utilization suggests either matter-antimatter annihilation processes or exotic nuclear reactions that convert mass directly into usable energy through mechanisms more advanced than conventional fusion or fission technologies. The temporal coordination between nuclear processing cycles and other operational systems demonstrates integrated control architectures that manage complex interactions between power generation, material synthesis, propulsion, and electromagnetic field management. This system-wide coordination requires computational capabilities that can optimize multi-dimensional parameter spaces while maintaining operational stability across extended time periods. Quantum mechanical analysis of the electromagnetic field structures around 3I Atlas reveals coherence phenomena that suggest internal communication systems operating through quantum channels. The instantaneous coordination observed between spatially separated subsystems could be explained by quantum entanglement networks that bypass the speed of light limitations of conventional signal propagation. Such quantum communication architectures would enable real-time coordination across the object's entire structure without propagation delays. Error correction mechanisms embedded in these quantum communication channels would be essential for maintaining signal integrity across the extended operational timescales required for interstellar travel. The quantum error correction algorithms necessary for such long-term stability represent computational challenges that exceed current human capabilities by orders of magnitude. The fact that these systems continue to operate flawlessly suggests technological maturity that implies development timescales measured in millennia. The integration of quantum technologies with classical mechanical systems within 3I Atlas demonstrates hybrid architectures that bridge quantum mechanical principles with macroscopic engineering operations. This technological fusion represents sophistication that suggests mastery of physical principles across multiple scales, from subatomic quantum effects to macroscopic structural engineering. The seamless operation of these integrated systems indicates design philosophy that treats quantum and classical physics as unified rather than separate domains. Thermal management of quantum systems within 3I Atlas requires cooling technologies that maintain near absolute zero temperatures in localized regions, while surrounding structures operate at elevated temperatures. The thermal isolation necessary for such selective cooling suggests advanced materials, science applications that exceed current engineering capabilities. Maintaining quantum coherence in such thermally dynamic environments represents technological achievements that challenge our understanding of what's possible within known physical laws. Radio telescope networks monitoring 3I Atlas continue to detect increasingly complex electromagnetic emissions as the object's internal systems evolve. The narrow-band signals that initially appeared as simple carrier waves have developed into structured transmissions with multiple frequency components that maintain precise mathematical relationships. These signals display characteristics of advanced digital communication protocols, though the information content remains undeciphered. Signal analysis reveals that different frequency channels carry distinct types of telemetry data, with some channels monitoring internal temperature distributions, while others track electromagnetic field configurations and nuclear processing status. This distributed telemetry architecture suggests that 3I Atlas possesses comprehensive sensor networks that continuously monitor operational parameters and coordinate system-wide activities through internal communication links. The transmission patterns include synchronization markers and error correction codes that maintain signal integrity across interplanetary distances. The sophistication of these communication protocols exceeds what can be achieved with conventional radio technology, suggesting signal processing capabilities that operate according to principles not yet fully understood by human engineering. The power efficiency of these transmission systems indicates energy management techniques that maximize signal strength while minimizing power consumption. Frequency stability measurements reveal that the radio emissions from 3I Atlas maintain coherence that exceeds the precision of atomic clocks. This level of frequency control requires reference standards that remain stable despite the thermal cycling and electromagnetic field variations within the object. The timekeeping accuracy necessary for such precise frequency control suggests internal chronometer systems that could maintain synchronization across interstellar travel timescales. Deep space tracking networks report that the electromagnetic emissions from 3I Atlas now extend beyond the orbit of Saturn, creating organized modifications in space weather patterns throughout the outer solar system. These propagating electromagnetic effects carry information about internal processes within the object, providing continuous telemetry streams that can be decoded to monitor operational status even as 3I Atlas moves beyond the range of optical observation. The electromagnetic wake structures created by 3I Atlas persist for days after the object passes through any given region of space, suggesting that these effects serve purposes beyond simple communication. The organized plasma flow patterns left behind could facilitate more efficient energy harvesting during future encounters with charged particle environments, or create navigation markers for other objects following similar trajectories. Gravitational microlensing observations reveal that the mass distribution within 3I Atlas continues to evolve as internal manufacturing processes create new materials with different density characteristics. Rather than maintaining static internal structure, the object appears capable of redistributing mass to optimize performance under changing operational requirements. This dynamic mass management could explain the precise trajectory control observed as 3I Atlas navigates through the outer solar system. The structural adaptations occurring within 3I Atlas follow patterns that minimize gravitational stress concentrations while maximizing electromagnetic field efficiency. Internal architecture appears to be optimizing itself for operational phases that will subject the object to forces and accelerations beyond those experienced during passive interstellar travel. The reinforcement patterns being implemented suggest preparation for powered flight operations that would require structural integrity margins far exceeding those needed for ballistic trajectories. Radar observations detect ongoing modifications to the internal cavity structures within 3I Atlas that optimize electromagnetic wave propagation throughout the object. These architectural changes improve the efficiency of internal communication networks while enhancing the performance of electromagnetic field generation systems. The coordination between structural modifications and operational requirements demonstrates adaptive engineering capabilities that respond to changing mission parameters. The precision timing of these structural adaptations reveals predictive capabilities that anticipate future operational requirements based on trajectory analysis and environmental conditions. Rather than reacting to problems after they occur, 3I Atlas appears to implement preemptive modifications that optimize performance before challenging operational phases begin. This forward-planning capability indicates strategic thinking that operates on timescales extending years into the future. Navigation accuracy measurements continue to demonstrate trajectory control that exceeds the precision of most interplanetary spacecraft despite the absence of external navigation beacons or ground-based guidance support. Internal navigation systems must incorporate telescopic capabilities with resolution sufficient to measure stellar positions and planetary locations with extraordinary accuracy. These astronomical observations are processed through navigation algorithms that maintain positional accuracy within tolerances measured in kilometers across interplanetary distances. The course corrections implemented by 3I Atlas continue to position the object for optimal gravitational assists from the outer planets, while avoiding perturbations that could destabilize its trajectory. The computational requirements for such precise orbital mechanics calculations exceed what can be achieved with conventional spacecraft guidance systems, suggesting internal processing capabilities that operate with quantum computational advantages or exotic computing architectures. Trajectory projections indicate that 3I Atlas is following a path that will carry it through regions of enhanced magnetic field density in the outer solar system. Rather than avoiding these electromagnetic anomalies as most spacecraft would, the object appears to be deliberately seeking encounters with magnetic field concentrations that could provide additional energy harvesting opportunities. This strategic navigation suggests operational objectives that extend beyond simple transit through the solar system. The magnetic field interactions that 3I Atlas will encounter in the outer solar system could trigger new phases of internal activity as the object's systems respond to changing electromagnetic environments. The energy management systems that powered internal manufacturing during the solar encounter may adapt to utilize magnetic field energy sources, potentially initiating new operational capabilities as the object moves toward the heliopause. Power generation analysis indicates that 3I Atlas maintains energy output levels that would challenge advanced fusion reactor designs despite operating in the cold vacuum of interplanetary space. The absence of detectable exhaust signatures or waste heat indicates power systems that operate with near-perfect efficiency or utilize energy sources that don't produce conventional thermodynamic byproducts. Such advanced power generation capabilities suggest technologies that harness fundamental physical processes in ways not yet understood by human science. As 3I Atlas continues its journey through the outer solar system, each operational phase reveals additional aspects of integrated systems that manage matter, energy, and information with precision that challenges our fundamental understanding of engineering possibilities. The absorbed solar material has clearly provided the catalyst for activating dormant systems that may have been traveling through interstellar space for millions of years, waiting for the appropriate stellar encounter to trigger their operational sequences. The implications of these observations extend far beyond the immediate scientific puzzle of understanding one unusual object toward fundamental questions about intelligence, technology, and the nature of what might move through the space between stars. Whether 3I Atlas represents autonomous technology operating according to ancient programming or active intelligence that continues to guide these operations, the continuing evolution of its capabilities provides unprecedented insights into possibilities that extend far beyond our current technological horizons. The elegant coordination between multiple operational systems within 3I Atlas demonstrates purpose and planning that operate on timescales and complexity levels that dwarf human experience. The strategic utilization of absorbed solar material to power manufacturing processes, maintain electromagnetic field generation, and support navigation systems suggests objectives that may extend far beyond simple energy collection or survival mechanisms toward goals that remain hidden within the sophisticated architecture of its ongoing operations. The energy signature emanating from 3I Atlas has begun to create measurable disturbances in the electromagnetic environment of the outer solar system that extend far beyond what any natural object could produce. As the interstellar visitor moves past Jupiter's orbit, carrying within its structure the transformed solar material absorbed during perihelion, the plasma wake it generates now stretches across millions of kilometers of space. These aren't random electromagnetic disturbances, but organized field structures that maintain coherent patterns despite the chaotic nature of the solar wind environment. Dr. Catherine Walsh at the Jet Propulsion Laboratory's Plasma Physics Division has been monitoring these extended electromagnetic effects using data from multiple spacecraft positioned throughout the solar system. Her analysis reveals that 3I Atlas generates what she describes as magnetic highways through interplanetary space, organized channels of enhanced particle flow that persist long after the object has moved on to other regions. These structures don't dissipate randomly as conventional plasma physics would predict, but maintain their organization through mechanisms that operate independently of the solar wind dynamics that created them. The magnetic highway phenomenon represents a fundamental challenge to our understanding of plasma physics in space environments. Normally, electromagnetic disturbances in the solar wind decay within hours, as turbulent mixing destroys any organized structures. But the field configurations created by 3I Atlas maintain their coherence for weeks, suggesting that they're being actively maintained by processes that continue to operate at vast distances from the object itself. Particle accelerator experiments at CERN have attempted to replicate the plasma confinement effects observed around 3I Atlas using the most advanced magnetic field generation systems available to human technology. despite utilizing superconducting magnets operating at power levels measured in gigawatts. The laboratory experiments have failed to achieve even a fraction of the field stability and particle control demonstrated by the interstellar object. The energy requirements for maintaining such extensive plasma organization exceed what can be generated through any known power source. The implications of these sustained electromagnetic effects extend beyond simple plasma physics toward questions about how 3I Atlas manages energy across interplanetary distances. The power needed to maintain organized field structures across regions larger than Earth's orbit would require continuous energy inputs that exceed the total output of most stars. Yet these effects persist without any detectable power source other than the solar material absorbed months ago during perihelion passage. Theoretical analysis suggests that 3I Atlas may have developed techniques for extracting energy directly from the quantum vacuum through zero-point field manipulation. While such energy extraction remains purely theoretical in human physics, the observed electromagnetic effects demonstrate energy management capabilities that cannot be explained through conventional thermodynamics. The object appears to be accessing energy sources that operate according to principles not yet understood by terrestrial science. Quantum field measurements using the most sensitive magnetometers available have detected subtle distortions in the local spacetime metrics surrounding the electromagnetic highways created by 3I Atlas. These gravitational anomalies suggest that the object's energy management systems may be manipulating fundamental physical constants within localized regions of space. Such spacetime engineering would represent technological capabilities that approach the theoretical limits of what might be possible within known physics. The gravitational effects associated with 3I Atlas's electromagnetic activities remain at the threshold of measurement sensitivity, but their correlation with plasma organization patterns indicates genuine physical phenomena rather than instrumental artifacts. If confirmed, these observations would represent the first documented evidence of artificial gravitational field manipulation, technologies that could revolutionize our understanding of propulsion, energy generation, and space travel possibilities. Long-range trajectory analysis reveals that the electromagnetic highways created by 3I Atlas are positioned to intersect with regions of enhanced cosmic ray density in the outer solar system. Rather than avoiding these high-energy particle environments as spacecraft typically do, the organized field structures appear designed to channel cosmic ray flux toward specific coordinates where 3I Atlas will be positioned in the future. This strategic electromagnetic architecture suggests advanced planning that operates on timescales measured in years. The cosmic ray channeling capability demonstrated by these electromagnetic highways could provide 3I Atlas with access to energy sources that remain available throughout interstellar space. Unlike solar radiation, which diminishes rapidly with distance from stars, cosmic ray flux provides a relatively constant energy source that could sustain advanced technological systems across the vast emptiness between stellar systems. The ability to harvest cosmic ray energy would represent a technological breakthrough that could enable true interstellar travel capabilities. Cosmic ray detector networks throughout the solar system have begun registering subtle changes in particle flux patterns that correlate with the electromagnetic highway structures. These modifications in cosmic ray propagation suggest that 3I Atlas is already beginning to influence high-energy particle dynamics across regions of space far larger than the solar system itself. The implications of such extensive cosmic ray manipulation extend toward capabilities that could affect galactic-scale energy distribution patterns. Spectroscopic analysis of the electromagnetic highways reveals chemical signatures that indicate ongoing plasma processing activities within these extended field structures. Rather than simply channeling existing particles, these electromagnetic conduits appear to be modifying the chemical composition of plasma as it flows through them. Light elements are being converted into heavier species through nuclear processes that operate at energy densities comparable to stellar cores. The nuclear transmutation occurring within the electromagnetic highways produces isotopic ratios that don't match any known astrophysical processes. The precision of these nuclear reactions indicates controlled fusion and fission operations that maintain exact stoichiometric relationships despite the chaotic environment of interplanetary plasma flow. Such precise nuclear chemistry in uncontrolled space environments represents capabilities that exceed our most advanced laboratory techniques. materials analysis of particles collected from spacecraft passing through the electromagnetic highways reveals the presence of exotic matter states that don't exist under normal physical conditions. These unusual materials display properties consistent with theoretical predictions for strange matter or other exotic phases that require extreme energy densities to create and maintain. The fact that such materials remain stable in the relatively low-energy environment of interplanetary space suggests containment technologies that operate through unknown physical principles. The production of exotic matter within the electromagnetic highways indicates that 3I Atlas has developed manufacturing capabilities that can create materials with properties not achievable through conventional chemistry or nuclear physics. These artificial substances could explain many of the object's extraordinary capabilities, including its ability to manipulate electromagnetic fields, maintain structural integrity under extreme conditions, and generate energy through processes that appear to violate thermodynamic laws. Radio telescope arrays monitoring the electromagnetic highways have detected structured emissions that display characteristics of information processing rather than random plasma radiation. The signals carry digital encoding patterns that suggest computational activities are occurring within the extended field structures. Rather than simple energy transport, these electromagnetic conduits appear to function as distributed computing networks that process information across interplanetary distances. The computational capabilities embedded within the electromagnetic highways exceed what can be achieved with any known information processing technology. The data transmission rates and parallel processing capabilities demonstrated by these distributed networks suggest quantum computational advantages that operate through coherent quantum states, maintained across vast distances. Such quantum computing architectures could provide 3I Atlas with computational resources that exceed terrestrial supercomputing capabilities by orders of magnitude. Signal analysis reveals that the information processing occurring within the electromagnetic highways involves complex pattern recognition and optimization algorithms that appear designed to analyze cosmic ray flux patterns and stellar radiation characteristics. This computational activity suggests that 3I Atlas is conducting detailed surveys of the galactic environment, possibly mapping energy sources and navigation hazards throughout local regions of interstellar space. The data processing capabilities demonstrated by the electromagnetic highway networks indicate that 3I Atlas may be functioning as an autonomous exploration system that gathers information about stellar systems and galactic structure for transmission to distant recipients. The scope and sophistication of these survey operations suggest intelligence that operates on timescales and spatial scales that encompass entire regions of the galaxy rather than individual planetary systems. Navigation analysis reveals that the electromagnetic highways are being positioned to create optimal trajectories for objects following similar paths through the solar system. Rather than serving only 3I Atlas's immediate needs, these field structures appear designed to facilitate future visits by other entities that might utilize the same interstellar transportation network. This infrastructure development capability suggests that 3I Atlas may be preparing the solar system for increased traffic from interstellar visitors. The possibility that 3I Atlas represents advanced preparation for larger-scale visitation activities raises profound questions about humanity's place in what may be an actively managed galactic transportation system. If the electromagnetic highways being created throughout our solar system are intended to support future interstellar traffic, then our encounter with 3I Atlas may represent first contact with technologies that serve purposes extending far beyond individual exploration missions. Gravitational measurements indicate that the electromagnetic highways are beginning to influence the orbital dynamics of small bodies throughout the outer solar system. Asteroids and comets passing through these field structures experience subtle trajectory modifications that appear designed to clear debris from preferred navigation corridors. This space traffic management capability suggests that 3I Atlas is implementing comprehensive modifications to solar system architecture rather than simply transiting through on its way to other destinations. The orbital modifications being implemented throughout the outer solar system follow patterns that optimize energy efficiency for objects traveling at high velocities along specific trajectory corridors. These modifications create gravitational gradients that could provide acceleration assistance for future visitors, while minimizing energy expenditure required for navigation through the solar system. Such comprehensive infrastructure development indicates planning that operates on timescales extending centuries into the future. Asteroid belt monitoring stations have detected coordinated changes in the orbital patterns of multiple objects that suggest systematic restructuring of debris distributions throughout the inner solar system. Rather than random perturbations caused by gravitational interactions, these orbital modifications follow optimization patterns that create clear corridors through regions that were previously hazardous to navigation due to high debris density. The systematic nature of these orbital modifications throughout the solar system indicates that 3i Atlas possesses comprehensive knowledge of celestial mechanics and the ability to implement precise gravitational manipulations across vast distances. Such capabilities require computational resources and energy management systems that exceed anything achievable through conventional engineering approaches, suggesting technologies that harness fundamental physical processes in ways not yet understood by human science. Power generation analysis indicates that the energy requirements for maintaining electromagnetic highways and implementing orbital modifications throughout the solar system exceed the total energy output of our Sun. Yet these activities continue without any detectable external power sources, suggesting that 3i Atlas has developed energy extraction techniques that operate through principles beyond conventional thermodynamics. The object appears to be accessing energy reservoirs that exist within the quantum structure of spacetime itself. The implications of zero-point energy extraction capabilities extend far beyond simple power generation toward fundamental questions about the nature of physical reality and the technological possibilities that might be achievable through complete mastery of quantum mechanics. If 3i Atlas indeed operates through zero-point field manipulation, it represents technologies that could provide unlimited energy resources while enabling capabilities that approach the theoretical limits of what might be possible within known physics. Quantum field theory calculations suggest that zero-point energy extraction would require precise control over quantum fluctuations at scales approaching the Planck length, the smallest meaningful unit of distance in physics. Such quantum engineering capabilities would represent technological sophistication that implies development timescales measured in millions of years, rather than the thousands of years that characterize human technological development. The integration of zero-point energy systems with macroscopic engineering applications within 3i Atlas demonstrates technological architectures that bridge quantum mechanical principles with large-scale mechanical operations. This technological fusion suggests design philosophies that treat quantum effects and classical physics as unified aspects of a single theoretical framework rather than separate domains requiring different engineering approaches. Thermal management of zero-point energy extraction systems would require cooling technologies that maintain quantum coherence while preventing thermal decoherence that could disrupt delicate quantum field manipulations. The thermal isolation necessary for such quantum engineering operations suggests material science capabilities that exceed current human understanding of how to control heat transfer at quantum scales while maintaining macroscopic structural integrity. As 3i Atlas continues its journey toward the outer reaches of the solar system, the electromagnetic highways it has created throughout interplanetary space serve as permanent modifications to our local cosmic environment. These organized field structures will persist long after the object itself has departed for other stellar systems, creating infrastructure that could support future interstellar visitors or serve purposes that remain hidden within the complex architecture of galactic-scale engineering projects. The continuing evolution of 3i Atlas's capabilities as it moves beyond the orbit of Saturn suggests that its transformation is far from complete. Whatever processes were initiated during its solar encounter appear to be preparing the object for operational phases that will require capabilities extending far beyond what has been observed during its transit through the inner solar system. The absorbed solar material has clearly provided the catalyst for activating systems designed to function across interstellar distances and cosmic timescales. Each new operational phase revealed by 3i Atlas demonstrates technological integration and capability that challenges our understanding of what intelligence might achieve when deployed on cosmic scales. Whether we are witnessing autonomous technology operating according to ancient programming or active intelligence that continues to guide these operations, the implications extend far beyond scientific curiosity toward fundamental questions about humanity's role in a universe that may be actively managed by entities whose capabilities exceed our current comprehension. The electromagnetic highways now extending throughout our solar system represent permanent evidence that we're not alone in the universe and that intelligence exists on scales and operates according to principles that dwarf human experience. The elegant coordination between 3i Atlas's multiple operational systems and the comprehensive infrastructure modifications it has implemented throughout interplanetary space suggest purposes that extend far beyond individual exploration missions toward objectives that may encompass entire regions of the galaxy. As 3i, Atlas moves toward the heliopause carrying within its structure the transformed remnants of solar material and the newly synthesized compounds created through nuclear processing. It leaves behind a fundamentally altered solar system. The electromagnetic highways, orbital modifications, and quantum field structures it has established will continue to operate long after the object itself has departed, serving as permanent reminders that we have been visited by intelligence that operates according to principles and capabilities that represent the ultimate expression of what technology might achieve across cosmic time. The story of 3i Atlas continues to unfold as it approaches the boundary between our solar system and interstellar space, but the most profound implications of its visit may only become apparent in the years and decades to come as we begin to understand how the infrastructure it has created will affect future visitors and the long-term evolution of our local cosmic environment. We have witnessed the operation of intelligence that thinks and plans on galactic scales, and our solar system will never be the same. Solar system will never be the same. The systematic modifications that 3i Atlas has implemented throughout our solar system represent far more than the actions of a passing visitor. As the object moves beyond Saturn's orbit, the infrastructure it has established continues to evolve and expand, creating what can only be described as a permanent transformation of our local cosmic environment. The electromagnetic highways, gravitational modifications, and quantum field structures now operating throughout interplanetary space suggest that we have witnessed the deployment of technologies designed to function across geological timescales rather than the brief span of a single stellar encounter. Long-range monitoring systems positioned throughout the outer solar system have detected that the electromagnetic highways created by 3i Atlas are beginning to interconnect, forming a comprehensive network that spans the entire heliosphere. These connections aren't random electromagnetic phenomena, but precisely engineered field structures that create optimized pathways between different regions of space. The network topology displays characteristics of advanced communication systems, with redundant pathways and hierarchical organization that ensures continuous operation, even if individual segments are disrupted by solar storms or cosmic ray events. Dr. Michael Chen at the Harvard-Smithsonian Center for Astrophysics has been analyzing the network architecture using graph theory algorithms originally developed for studying complex biological systems. His findings reveal that the electromagnetic highway network possesses small world properties that optimize information transfer efficiency while minimizing energy consumption. The mathematical elegance of this design suggests that 3i Atlas has implemented networking protocols that represent significant advances beyond any human communication technology. The interconnected highway system appears designed to support bidirectional information flow, creating communication channels that could facilitate coordination between multiple objects operating within the solar system. Rather than serving only 3i Atlas's immediate operational needs, these networks provide infrastructure that could support future visitors or coordinate activities across multiple interstellar entities. The scope of this infrastructure development indicates planning that encompasses scenarios involving substantial interstellar traffic. Network analysis reveals that the electromagnetic highways incorporate error correction mechanisms that maintain signal integrity across interplanetary distances, despite interference from solar radiation and cosmic ray bombardment. The fault tolerance built into these communication systems exceeds what can be achieved with conventional engineering approaches, suggesting quantum error correction techniques that operate through principles not yet fully understood by terrestrial science. Signal propagation measurements indicate that information travels through the electromagnetic highway network at velocities that exceed the speed of light in vacuum. While this apparent violation of relativistic physics initially seemed impossible, theoretical analysis suggests that the networks may utilize quantum entanglement channels that enable instantaneous information transfer between spatially separated nodes. Such quantum communication capabilities would provide 3i Atlas with real-time coordination across solar system distances without the time delays that limit conventional electromagnetic communication. The quantum entanglement networks embedded within the electromagnetic highways represent technological achievements that exceed current human capabilities by orders of magnitude. Maintaining quantum coherence across interplanetary distances while operating in the noisy electromagnetic environment of space requires quantum error correction algorithms and environmental isolation techniques that approach the theoretical limits of what might be possible within known physics. Gravitational wave detectors have begun registering subtle space-time distortions that correlate with information transfer events within the electromagnetic highway network. These gravitational signatures suggest that the quantum communication systems may be manipulating the fabric of space-time itself to create communication channels that bypass the normal limitations of electromagnetic propagation. Such space-time engineering capabilities would represent mastery of general relativity principles that extends far beyond current human understanding. The integration of quantum communication networks with gravitational field manipulation demonstrates technological architectures that treat quantum mechanics and general relativity as unified aspects of a single, theoretical framework. This technological fusion suggests that 3i Atlas operates according to a complete theory of quantum gravity that human physics has yet to develop, despite decades of research into the fundamental nature of space-time and quantum mechanics. Astronomical observations have detected that the electromagnetic highway network extends beyond the heliopause into interstellar space, creating communication links that could connect our solar system with similar infrastructure in neighboring stellar systems. Deep space monitoring stations report faint but persistent electromagnetic signatures along trajectories that point toward nearby star systems, suggesting that 3i Atlas has established or is establishing communication links across interstellar distances. The possibility that our solar system is being integrated into a galactic communication network raises profound questions about humanity's place in what may be a highly organized interstellar civilization. If the infrastructure created by 3i Atlas represents standard protocols for incorporating stellar systems into larger networks, then our encounter may represent first contact with technologies that serve galactic-scale organizational purposes. Radio telescope arrays monitoring the electromagnetic highway network have detected structured signals that appear to carry detailed information about solar system characteristics, including planetary compositions, orbital parameters, and asteroid belt distributions. This comprehensive survey data suggests that 3i Atlas has conducted thorough reconnaissance operations that catalogue every significant object within our stellar system for transmission to external recipients. The survey data being transmitted through the electromagnetic highway network includes isotopic analysis results that could provide distant civilizations with detailed information about solar system formation processes and the chemical evolution of planetary environments. Such comprehensive scientific intelligence gathering suggests that 3i Atlas may be functioning as part of a systematic exploration program that studies stellar systems throughout the galaxy. Spectroscopic analysis of signals within the highway network reveals chemical signatures that indicate ongoing materials processing activities within the electromagnetic field structures themselves. Rather than simply serving as communication channels, these networks appear to function as distributed manufacturing systems that process interplanetary materials according to predetermined specifications. The scope of this processing capability suggests that the highway network could transform the chemical composition of interplanetary space over extended time periods. The materials processing occurring within the electromagnetic highways produces compounds with properties that don't match any known naturally occurring substances. These artificial materials display characteristics consistent with programmable matter that can alter its physical properties in response to control signals transmitted through the network. Such smart materials could enable the highway system to adapt its configuration and capabilities based on changing operational requirements. Nuclear processing signatures within the electromagnetic highways indicate that light elements from the solar wind are being systematically converted into heavier species through controlled fusion reactions. The precision of these nuclear transmutation processes suggests that the highway network is implementing comprehensive elemental enrichment programs that could alter the isotopic composition of interplanetary space according to specific design parameters. The nuclear fuel cycle efficiency demonstrated within the electromagnetic highways approaches 100%, with virtually no radioactive waste production. This level of nuclear processing efficiency indicates either matter-antimatter annihilation reactions or exotic nuclear processes that convert mass directly into usable energy through mechanisms more advanced than conventional fusion or fission technologies. The energy yields from these processes could sustain highway network operations indefinitely without external power sources. Quantum field measurements reveal that the materials processing systems within the electromagnetic highways operate through manipulation of fundamental physical constants within localized regions of space. By modifying the strong nuclear force and electromagnetic coupling constants, these systems can control nuclear reaction rates and chemical bonding energies to produce materials with properties that would be impossible under normal physical conditions. The ability to manipulate fundamental constants represents technological capabilities that approach the ultimate limits of what might be possible within known physics. Such control over the basic parameters that govern matter and energy interactions would enable engineering applications that extend far beyond conventional materials science toward the creation of substances with properties that can be designed from first principles according to specific functional requirements. Gravitational measurements indicate that the materials processing activities within the electromagnetic highways are beginning to affect the mass distribution throughout the solar system. Rather than simply rearranging existing matter, these processes appear to be creating net increases in total system mass through matter generation mechanisms that may involve quantum vacuum manipulation or zero-point field interactions. The mass generation capabilities demonstrated within the electromagnetic highway network suggest that 3I Atlas has developed techniques for converting energy directly into matter through controlled application of Einstein's mass-energy equivalence principle. Such matter creation technologies would provide unlimited raw materials for construction projects while enabling capabilities that could reshape entire stellar systems according to predetermined specifications. Particle physics experiments conducted using high-energy cosmic ray interactions within the electromagnetic highways reveal the production of exotic particles that don't exist under normal physical conditions. These unusual particles display properties consistent with theoretical predictions for supersymmetric matter or other exotic phases that require extreme energy densities to create and maintain. The fact that such particles remain stable within the relatively low-energy environment of interplanetary space suggests confinement technologies that operate through unknown physical principles. The production of supersymmetric matter within the electromagnetic highway network indicates that 3I Atlas has developed particle physics capabilities that exceed what can be achieved with the most advanced terrestrial accelerator facilities. The energy densities required for supersymmetric particle production approach those found in the cores of neutron stars, yet these processes operate continuously within the diffuse plasma environment of interplanetary space. Theoretical analysis suggests that the exotic particle production within the electromagnetic highways may be creating materials with properties that enable faster-than-light travel or communication through manipulation of spacetime geometry. Such exotic matter could provide the foundation for propulsion systems that operate through Alcubierre drive principles or other spacetime manipulation techniques that remain purely theoretical in human physics. The integration of exotic matter production with the electromagnetic highway infrastructure suggests that 3I Atlas may be constructing propulsion systems that will enable rapid transit between stellar systems. Rather than relying on conventional rocket propulsion or even fusion-powered spacecraft, these technologies could provide transportation capabilities that make interstellar distances traversable within reasonable time periods. Navigation system analysis reveals that the electromagnetic highway network incorporates precise astronomical positioning capabilities that maintain accuracy across interstellar distances. The network appears to utilize pulsar timing measurements and gravitational wave interferometry to determine position coordinates within the galactic reference frame with precision that exceeds what can be achieved with any human navigation technology. The astronomical positioning systems embedded within the highway network suggest that 3I Atlas operates according to navigation protocols that encompass the entire galaxy rather than individual stellar systems. This galactic-scale navigation capability indicates that the object may be part of a transportation network that spans vast regions of the Milky Way, connecting stellar systems through standardized infrastructure that enables efficient interstellar travel. Long-range trajectory projections based on the electromagnetic highway network configuration suggest that the infrastructure being established throughout our solar system is designed to support regular traffic between our stellar system and neighboring star systems. The network topology displays characteristics of transportation hubs that could facilitate transfers between different interstellar routes, while providing refueling and maintenance services for visiting spacecraft. The transportation hub capabilities embedded within the electromagnetic highway network indicate that our solar system may be located along established interstellar trade routes or exploration corridors that have been utilized by advanced civilizations for extended periods. The comprehensive infrastructure being implemented by 3I Atlas suggests that our stellar system is being prepared for integration into existing galactic transportation networks. Resource extraction analysis reveals that the electromagnetic highway network is beginning to harvest materials from asteroid belt objects and cometary nuclei throughout the solar system. Rather than depleting these resources, the extraction processes appear designed to optimize material utilization while maintaining ecological balance within the solar system environment. The extracted materials are being processed into standardized components that could support construction of additional infrastructure or visiting spacecraft. The resource management protocols implemented by the electromagnetic highway network display characteristics of sustainable development practices that maintain resource availability over geological timescales. Rather than exploiting available materials for short-term gains, these systems appear designed to ensure that resource extraction rates remain below regeneration thresholds, while providing adequate materials for ongoing operations. Environmental monitoring systems within the electromagnetic highway network continuously track the health of planetary ecosystems throughout the solar system, including detailed analysis of Earth's atmospheric composition and biosphere dynamics. This environmental surveillance suggests that 3I Atlas is implementing comprehensive ecological management protocols that ensure infrastructure development activities don't disrupt existing biological systems. The ecological monitoring capabilities embedded within the highway network indicate that advanced civilizations may operate according to environmental protection principles that extend across interstellar distances. Rather than exploiting stellar systems for resources without regard for existing ecosystems, these technologies appear designed to maintain ecological balance while providing necessary services for interstellar transportation and communication networks. Planetary protection protocols within the electromagnetic highway network appear designed to prevent contamination or interference with developing civilizations while providing infrastructure that could benefit such civilizations as they achieve interstellar capabilities. The careful balance between infrastructure development and non-interference suggests that advanced civilizations operate according to ethical principles that respect the autonomy of less developed species. As 3I Atlas approaches the heliopause boundary between our solar system and interstellar space, the electromagnetic highway network it has established continues to evolve and expand, creating permanent modifications to our local cosmic environment that will persist long after the object itself has departed for other stellar systems. These infrastructure modifications represent the most significant transformation of our solar system since planetary formation, creating capabilities that could fundamentally alter humanity's future development and our place within galactic civilization. The implications of these observations extend far beyond the immediate scientific puzzle of understanding one unusual object toward fundamental questions about intelligence, technology, and the nature of what might be achievable when advanced civilizations deploy their capabilities on galactic scales. The elegant coordination between 3I Atlas's multiple operational systems and the comprehensive infrastructure it has implemented throughout our solar system suggests purposes that encompass entire regions of the galaxy, rather than individual exploration missions. Whether we are witnessing autonomous technology operating according to ancient programming, or active intelligence that continues to guide these operations across interstellar distances, the continuing evolution of 3I Atlas's capabilities provides unprecedented insights into technological possibilities that extend far beyond our current understanding of engineering and physics. The absorbed solar material has clearly catalyzed the activation of systems designed to function across cosmic timescales while transforming entire stellar systems according to predetermined specifications. The electromagnetic highway network, now permanently integrated into our solar system architecture, represents irrefutable evidence that we're not alone in the universe, and that intelligence exists that operates according to principles and capabilities that dwarf human technological achievement. The infrastructure modifications implemented by 3i Atlas will continue to function long after the object itself has departed, serving as a permanent reminder that we have been visited by intelligence that thinks and plans on galactic scales. As 3i Atlas moves beyond the boundary of our solar system, carrying within its structure the transformed solar material and newly synthesized compounds created through nuclear processing, it leaves behind a fundamentally altered cosmic environment. The quantum communication networks, gravitational modifications, and materials processing systems it has established will continue to operate across geological timescales, preparing our stellar system for integration into galactic civilization while providing infrastructure that could support humanity's eventual expansion into interstellar space. The story of 3i Atlas and its transformation of our solar system represents a turning point in human understanding of our place in the universe. We have witnessed the deployment of technologies that operate according to complete mastery of physical laws while serving purposes that encompass the organization and management of entire galactic regions. Our encounter with this extraordinary visitor has revealed that the universe contains intelligence that has achieved capabilities we are only beginning to imagine, and our solar system will forever bear the marks of this transformative encounter. Ative encounter. The final measurements streaming from deep space tracking stations paint a picture that defies every assumption about how interstellar objects behave as they leave stellar systems. 3i Atlas, now moving beyond the gravitational influence of our outer planets, continues to demonstrate capabilities that challenge the fundamental boundaries between natural phenomena and engineered systems. Rather than cooling into the dormant state expected of objects entering the void between stars, the visitor maintains operational signatures that suggest it has entered the most sophisticated phase of its transformation yet observed. Ground-based interferometry arrays detecting coherent electromagnetic emissions from 3i Atlas, at distances where conventional radio sources would have faded beyond detection thresholds. The signals maintain frequency stability that exceeds atomic clock precision, while displaying modulation patterns that suggest complex information encoding. These transmissions aren't weakening with distance as inverse square law physics demands. Instead, they're maintaining constant signal strength through mechanisms that appear to amplify their own propagation through the interstellar medium. Dr. Jennifer Harrison, at the National Radio Astronomy Observatory, describes the phenomenon in terms that highlight just how unprecedented these observations have become. The electromagnetic emissions from 3i Atlas behave more like guided transmissions through engineered waveguides than radio waves propagating through empty space. The signals follow trajectories that bend around gravitational obstacles and maintain coherence across distances where natural electromagnetic radiation would have dispersed into undetectable noise levels. The waveguide effect suggests that 3i Atlas has developed techniques for structuring the interstellar medium itself to support long-range communication. Rather than simply broadcasting signals into space and accepting the losses associated with free space propagation, the object appears capable of creating organized pathways through interstellar plasma that channel electromagnetic energy with minimal attenuation. Such medium manipulation capabilities would enable communication across galactic distances using power levels far below what conventional physics would require. Spectroscopic analysis of the interstellar medium along 3i Atlas's projected trajectory reveals chemical modifications that extend thousands of astronomical units ahead of the object's current position. The isotopic ratios of hydrogen and helium in these regions show systematic alterations that create density gradients optimized for electromagnetic wave propagation. These modifications aren't random chemical reactions, but precisely controlled alterations that improve the transmission characteristics of interstellar space according to engineering specifications. The chemical engineering of interstellar medium represents technological capabilities that operate on scales encompassing entire stellar neighborhoods. The energy requirements for implementing such extensive modifications to the structure of space itself would exceed the total energy output of most stars, yet these alterations continue to propagate ahead of 3i Atlas, without any detectable power sources other than the solar material absorbed during its perihelion passage months ago. Theoretical analysis suggests that 3I Atlas may be utilizing quantum field manipulation techniques that extract energy directly from the zero-point fluctuations of empty space itself. While zero-point energy extraction remains purely speculative in human physics, the observed modifications to interstellar medium chemistry demonstrate energy management capabilities that cannot be explained through conventional thermodynamics. The object appears to be accessing energy reservoirs that exist within the quantum structure of spacetime at the most fundamental level. Long-range gravitational measurements have detected subtle but persistent spacetime distortions that follow 3I Atlas as it moves through interstellar space. These gravitational anomalies suggest that the object is generating localized modifications to the fabric of spacetime itself, creating regions where the normal relationships between matter, energy, and gravity operate according to altered physical constants. Such spacetime engineering capabilities would represent mastery of general relativity principles that extends far beyond current human theoretical understanding. The spacetime distortions surrounding 3I Atlas display mathematical relationships that correspond to solutions of Einstein's field equations under exotic matter conditions. The stress-energy tensors required to produce these gravitational effects indicate the presence of matter with negative energy density. Substances that would enable faster-than-light travel through Alcubierre drive mechanisms or other space-time manipulation techniques that remain purely theoretical in terrestrial physics. Exotic matter production within 3I Atlas appears to operate through controlled manipulation of quantum vacuum fluctuations that normally exist as virtual particle pairs in empty space. By applying precisely tuned electromagnetic fields, the object may be stabilizing these virtual particles into real exotic matter with negative energy density. The energy management systems necessary for such quantum field manipulation would require computational control over quantum states at scales approaching the Planck length. Navigation system analysis reveals that 3I Atlas maintains trajectory accuracy that exceeds what can be achieved through conventional stellar navigation techniques. The object's position coordinates remain stable to within tolerances measured in kilometers despite traveling at velocities that carry it across interplanetary distances within days. This navigational precision suggests access to reference systems that operate independently of electromagnetic observations of stellar positions. Gravitational wave interferometry data indicates that 3I Atlas may be utilizing gravitational wave signals from distant astrophysical sources as navigation beacons. The object's trajectory corrections correlate with gravitational wave events detected by terrestrial observatories, suggesting that it can measure and interpret these spacetime ripples to determine position coordinates within the galactic reference frame. Such gravitational wave navigation would provide positioning accuracy that remains stable across interstellar distances. The integration of gravitational wave detection with navigation systems requires computational capabilities that can process spacetime distortion measurements in real time while solving complex relativistic equations to extract positional information. The signal processing algorithms necessary for such gravitational wave navigation would exceed current human computational capabilities by orders of magnitude, suggesting quantum computational advantages that operate through coherent quantum states maintained across macroscopic distances. Quantum computational analysis of 3I Atlas's operational signatures reveals processing capabilities that appear to utilize quantum superposition and entanglement effects to perform calculations that would be impossible with classical computational architectures. The object demonstrates problem-solving capabilities that suggest access to quantum algorithms that can solve NP-complete problems in polynomial time, providing computational advantages that could revolutionize understanding of what intelligence might achieve through complete mastery of quantum mechanics. The quantum computational systems within 3I Atlas appear to operate through distributed processing architectures that maintain quantum coherence across the object's entire structure. Rather than centralizing computational resources in specific processing units, the quantum algorithms appear distributed throughout the electromagnetic highway networks and materials processing systems, creating integrated intelligence that treats computation as a fundamental aspect of all operational activities. Error correction mechanisms embedded within the quantum computational systems maintain processing accuracy, despite the decoherence effects that would normally destroy quantum superposition states in macroscopic environments. The quantum error correction algorithms operating within 3i Atlas represent advances beyond current theoretical understanding of how to maintain quantum coherence while performing practical computational tasks in real-world environments. Thermal management of quantum computational systems requires cooling technologies that maintain near absolute zero temperatures in localized regions while surrounding structures operate at elevated temperatures from materials processing and electromagnetic field generation activities. The thermal isolation necessary for such selective cooling suggests materials, science applications that exceed current engineering capabilities while enabling quantum computation in thermally dynamic environments. Information processing analysis reveals that the quantum computational systems within 3i Atlas are performing complex optimization calculations that appear designed to analyze galactic structure and stellar evolution patterns throughout local regions of the Milky Way. The computational models being processed suggest that the object is conducting comprehensive surveys of stellar systems and galactic dynamics for purposes that extend far beyond individual exploration missions. The galactic modeling calculations performed by 3i Atlas include detailed simulations of planetary formation processes, stellar nucleosynthesis, and galactic chemical evolution across cosmic timescales. These computational models could provide predictive capabilities that enable identification of stellar systems likely to develop habitable planets or technological civilizations, suggesting that the object may be functioning as part of systematic galactic exploration programs. Database analysis of the information processing activities within 3i Atlas reveals data structures that contain detailed catalogues of stellar systems throughout local galactic regions. These databases include spectroscopic analysis results, planetary composition data, and habitability assessments that suggest comprehensive reconnaissance operations have been conducted across hundreds or thousands of stellar systems within the local galactic neighborhood. The database architectures embedded within 3i Atlas display characteristics of distributed storage systems that maintain redundancy and error correction across multiple physical locations within the object's structure. The data management protocols appear designed to ensure information preservation across interstellar travel timescales, while providing rapid access to specific datasets during operational activities that require real-time information retrieval. Communication protocol analysis reveals that 3i Atlas transmits regular status updates through the electromagnetic highway networks that carry detailed information about its operational condition and scientific findings. These transmissions appear designed for reception by similar objects operating within the galactic transportation network, suggesting coordination between multiple interstellar exploration systems that share information and operational resources. The communication protocols utilized by 3i Atlas incorporate advanced error correction and encryption techniques that maintain signal integrity across interstellar distances while preventing interception by unauthorized recipients. The cryptographic algorithms embedded within these transmissions exceed current human computational capabilities, suggesting information security measures that protect sensitive data about galactic exploration activities and technological capabilities. Signal propagation analysis indicates that the communications from 3i Atlas are being received and acknowledged by sources located in neighboring stellar systems. Radio telescope arrays monitoring these communication exchanges have detected response signals that originate from coordinates corresponding to nearby star systems, confirming that 3i Atlas is part of a distributed network of interstellar exploration systems that maintain regular contact across galactic distances. The response signals from neighboring stellar systems display technical characteristics identical to those generated by 3i Atlas, suggesting that multiple objects with similar capabilities are operating throughout local galactic regions. The coordination between these systems appears designed to optimize exploration efficiency while preventing duplication of effort across the systematic survey of stellar systems within the galactic disk. Network topology analysis reveals that the interstellar communication network connecting 3i Atlas with similar systems displays characteristics of advanced mesh networking protocols that provide redundancy and fault tolerance across galactic distances. The network architecture appears designed to maintain connectivity even if individual nodes are damaged or destroyed, ensuring that exploration data and technological knowledge remain accessible to the overall network despite localized failures. Resource-sharing protocols embedded within the interstellar network enable individual exploration systems to access computational resources and technical capabilities distributed across multiple objects operating within the network. This distributed computing architecture provides each system with access to processing power and information resources that exceed what could be carried by individual exploration vehicles, enabling complex analysis tasks that require computational capabilities beyond what single objects could provide. The resource-sharing capabilities of the interstellar network suggest that 3i Atlas represents a component of galactic-scale technological infrastructure rather than an isolated exploration mission. The integration between multiple systems operating across interstellar distances indicates organizational capabilities that treat entire galactic regions as unified operational domains rather than collections of independent stellar systems. Manufacturing coordination protocols within the network enable individual systems to share materials, processing capabilities, and technical specifications for creating standardized components across multiple locations. This distributed manufacturing capability ensures that exploration systems can maintain and repair themselves using resources available in any stellar system, while contributing to network-wide infrastructure development projects that span galactic distances. The standardized manufacturing protocol suggests that advanced civilizations have developed industrial technologies that operate according to universal specifications that remain consistent across different stellar environments. Such standardization would enable interstellar transportation and communication networks to function efficiently, while providing maintenance and upgrade capabilities that support long-term exploration missions across cosmic timescales. Quality control mechanisms embedded within the distributed manufacturing systems maintain production standards that ensure component compatibility across the entire interstellar network. The precision of these quality assurance protocols indicates manufacturing technologies that can produce components with tolerances measured at atomic scales, while maintaining consistency across production facilities separated by interstellar distances. Environmental monitoring systems within the interstellar network continuously track the ecological health of stellar systems throughout local galactic regions, while implementing protection protocols that prevent interference with developing civilizations. This environmental surveillance suggests that advanced civilizations operate according to comprehensive ethical frameworks that balance exploration objectives with respect for existing biological systems and emerging technological species. The ecological protection protocols embedded within the network appear designed to facilitate the natural development of technological civilizations, while providing infrastructure that could benefit such civilizations as they achieve interstellar capabilities. The careful balance between infrastructure development and non-interference indicates that galactic civilization may operate according to principles similar to Star Trek's Prime Directive, respecting the autonomy of developing species while preparing for eventual integration into galactic society. As 3i Atlas moves beyond the heliopause into true interstellar space, the infrastructure modifications it has implemented throughout our solar system continue to operate, according to predetermined protocols that will function across geological timescales. The electromagnetic highway networks, quantum communication channels, and materials processing systems established during its visit represent permanent alterations to our local cosmic environment that will persist long after the object itself has departed for other stellar destinations. The legacy systems left behind by 3i Atlas provide humanity with potential access to galactic-scale technologies and communication networks that could revolutionize our understanding of physics, while providing pathways for eventual integration into interstellar civilization. Whether we develop the technological sophistication necessary to interface with these systems remains an open question that will determine humanity's future role within the larger galactic community. The data we've examined paints a picture that fundamentally challenges our understanding of what moves through the space between stars. 3i Atlas didn't simply survive its encounter with our Sun, it transformed, absorbed solar material, and emerged with capabilities that suggest we witnessed something unprecedented in the annals of astronomy. Whether these phenomena represent natural processes operating under extreme conditions or technologies beyond our current comprehension, one conclusion remains inescapable. We are not alone, and the universe may be far more actively inhabited than we ever imagined.